Hi everyone, my name is Trevor Williams, and I'm your instructor for this free course on Entity Framework Core. Now, in this course, we take a step back. We're not going to be building out a whole application and looking at application development on a whole. Instead, we're going to focus on Entity Framework Core as an ORM, and we're going to look at different configuration options that are available to you when designing your database through code first development. So in this course, we're going to use a simple console app and we're going to look at different querying techniques, explore best practices, and overall develop the foundation that would be key to you building on top of Entity Framework Core for any other type of application development. Now, that being said, this is a free preview to the full course, and the link for that is available either in the tag coming up above or in the description below this video. Now, in the full course, you will get even more information about different techniques and options available to you when you use Entity Framework Core as your ORM in your application. So I encourage you to enroll in that course, and I know that you're going to get invaluable information that you can use in your future projects. Until then, however, do enjoy this free course, and I'll see you soon. Hey guys, welcome back. So in this lesson, I'm just going to walk you through what you need to set up your environment for this course. So I'm already here on the Visual Studio website. You can get there by saying visualstudio.microsoft.com. And what we're going to be using is the Visual Studio IDE Community Edition. Now, this is the flagship IDE given to us by Microsoft for .NET development. So it is perfect for this course. However, if you're not able to use that Community Edition on a Windows machine and you're using a Mac, then they have the Mac version. If you're not using a Mac, then you can use Visual Studio Code, which is also open source, completely free and available across every one of the operating system. Now, things I will be doing in this course will differ if you're using Visual Studio Code, but I will do my best to make notes along the way to try and make sure that you are able to carry out the operations. Now, after downloading Visual Studio, you'll be given, well, at least downloading the installer. After launching this installer, you'll be given a screen similar to this. Now, I already have it on my machine, and what you're seeing are the different workloads that I have already installed. You don't need this many for this particular course. If you already have the ones that I'm about to show you, then you can go ahead and skip this step. But if you are here and you need to know what to get, you need this .NET cross-platform development workload, which gives us the actual, the basic libraries for .NET core development. And we will be doing a little web activity, so it would be a good idea to just get the ASP.NET and web development workload also. So at the bare minimum, you need those two. The more you click, of course, the more that will be installed, so you don't have to click as many as you see me having ticked here. So ASP.NET and web development, as well as .NET cross-platform development. So you can go ahead and install those. Now, you need to complete this step, especially if you're not using the Visual Studio and a Windows machine, because if you're going to be using Visual Studio Code, then you need to install the SDK in the background. That comes with Visual Studio, right? But then if you're not using Visual Studio, once again, you can go ahead and download that SDK. So you can just get here by going to .net.microsoft.com, and from that landing page, you'll be able to navigate to the .NET 5 downloads page where you're going to be getting that SDK. You can also go ahead and get the runtimes because we'd need them for hosting, but at the very least, you need that SDK. Now, after everything has been installed and set up, you just want to make sure that everything is installed. So you can go to your command prompt, whichever OS you're on, and then you can just type .NET-H. All right, so when you do that, it will bring up, if you're seeing a printout to the screen looking something like this, then you're on the right path. So it will tell you the SDK version that you have, and it will just show you all of the different commands that you can use. So you can actually use these commands when creating a new .NET Core application. And especially, once again, if you're using Visual Studio Code, then you're definitely going to be using the .NET commands a bit more. All right, so that's really it for setting up the environment. This is a 5-minute video, but it will take probably a few hours, or a few more minutes rather than this if you are setting up from scratch, but it won't take too long. So as soon as you're done and you can verify that you have everything installed, then you can move on to the next lesson. All right, guys, so let us start setting up our solution for this course. So I have Visual Studio 2022, and what I'm going to do is create a new project. For this course, I'm going to be using a console app and some class libraries. And the reason we're using a console app is that if you can understand Entity Framework Core from a console app's perspective, just understanding the concepts, then the possibilities are going to be limitless when you actually have to use it in an application. So we'll start off with a tiny console app. And what I'm going to do is name this app Entity Framework Core .console app. And then I'm going to remove that .console app from the solution name, since there are going to be other projects. So the solution is Entity Framework Core, and our project name is Entity Framework Core .console app. Then we can hit next. Now we choose the version of the .NET framework that we wish to use. Now, the majority of the course was actually recorded using .NET 5. However, you can go to 6 or 7 because I do show Entity Framework Core 5, 6, and 7, all of which the functionality is compatible with each increment. As a matter of fact, Entity Framework Core 7 has features that can be leveraged from .NET 6. So if it is that you need to use .NET 6 for this course, then go right ahead because everything will still work. However, for this creation, I'm just going to use .NET 7, which at the time of recording is the latest and greatest. And then I'm going to tick do not use top level statements. And I actually find this kind of confusing because by ticking it out, it would imply to me that I don't get the program class and the main function. However, it's the opposite. So if you leave it unchecked, then you will get the simple program class without the overhead of the namespace and the class and the function. If you do tick it, then you'll get all of that. So for consistency, I am going to tick it, and then we can go ahead and hit create. And then we end up with our project. So now we have the program.cs file in that namespace. And then the cool thing is that we can save on some of the horizontal spacing. If we will just put a semicolon at the end of that namespace line, it gets rid of those braces. So that's optional for you. You can do that if you wish. I won't necessarily do it. Once again, in the name of consistency. Now we can add the other projects. So let us go ahead and add a class library. I'm just going to right click the solution, go to add new project, and this time we're adding a C# class library. Now if you have it to the side, you can always click class library here, or if not, you can always search for the template up top. And remember that we're dealing with C#. So I can just select class library, and I'm going to call this one Entity Framework Core.data. So I actually just copied the previous name, and I'm just changing that just to be a bit efficient. And then we are using a .NET 7 library to match the previous app. So if you use .NET 6, make sure you choose the appropriate option, all right? And then we hit create. And then the final project is another class library. So we just repeat those steps, go ahead and hit new project, choose the class library. And this time we're going to call it Entity Framework Core.domain. And once again, we're using the same version. All right, so just so we can understand why we have the 3 projects, project number 1, which is a console app, acts as our point of entry. So here you'll see the configuration. It knows it's an executable file. If you have any experience with console apps, you know that they'll just run in the command prompt looking window. So that is going to be where we put in our application logic, and we're doing all of the fancy stuff with Entity Framework. Now, there is a challenge here with the nullable, right? So this nullable configuration was introduced with .NET 6 to help us to, or help the compiler to point out where we might run into null references, and it gets very strict. So for this course, I'm just going to say disable, just so we can get through the course with fewer disruptions. But in my other courses, I do walk you through how to manage that. So right now you can just say nullable disable and you can proceed. Now, if you look at the other 2, we have the data, which is just a class library. And notice it also says .NET 7, and it also asks if it should practice that nullability. So we can disable that as well. And for the domain, so the data is going to have like our data configurations, and the domain project is going to have the actual domain models. And once again, we disable. So with those three projects created, what we're going to do next is go ahead and start having some fun. So stay tuned. Hey guys, welcome back. So in this lesson, we're going to start modeling our database tables. Now, what I have on screen is a database diagram, or ERD, entity relationship diagram. It goes by a few names and there are a few representations of it. But the fundamental concept is that it is a diagram showing the different entities or tables inside of a database, and what the primary key column is, what the other fields are, and then depicting that there is what we call a foreign key relationship between two tables. So here it is showing that we have teams and we have leagues. Those are two tables. The league has an ID, which we're going to make an auto incrementing integer, and it has a name. And then a team also has an ID, also has a name, but then it has a league ID. So this league ID is what we call a foreign key to the league. So a team belongs to a league. All right. So that's the kind of relationship. If you're familiar with database, then you already know what's going on. If you're not so familiar, then that's no problem. I hope you understand at least the concept behind this diagram. All right. So what we want to do though is set up tables like this inside of EF Core. So we want to use EF Core to model out a database that will generate these tables. So you have different conventions when it comes to developing on top of a database. So you can do it database first, meaning somebody went in, designed the database and everything, and then we start building the application afterwards. Or you have code first, which, even though it implies that the code comes first, what it really means is that we are going to write the code that is then turned into the database. So that way, if we need to change something down the line, we actually just change the code, and then we can let that make incremental changes to said database. And EF Core supports either one. That is the beauty of it. So for the majority of this course, we're going to be looking at code first and how we can make marginal changes or incremental changes as we go along, modifying the code. But we will look at how to reverse engineer an existing database into an EF Core set of files. All right. So enough talk. Let's get into that. So my data models or domain models are going to end up going in the domain project. All right. So I'm going to get rid of this default class that we got with it. And I'm going to go ahead and add a new class. And I'm going to call this class League. Now, generally speaking, I always advise my students, whenever you're creating a database, try to start off with the ones with the fewest dependencies and then go on, because you don't want to build a table that has 2, 3 foreign keys relating to other tables and those tables don't exist yet. So since in this situation, league is a standalone table, meaning league is there, a league is going to be there at least right now without any teams, but the team depends on the league, right? So we want league to exist first. So create that class. I'm going to make it public so that other projects can access it. And then inside of this, I'm going to have the two properties, ID and name. So we're going to say public int ID, public string name. So you see here, especially if you're familiar with the data types in SQL, you'll see that we're not saying varchar here, right? We're saying string. So EF Core will be able to translate the native C#, data types into the equivalent SQL data types. We'll see that later on. So that is one of the benefits. We can use our native C# inside of our EF Core application, and the translation to the database will happen anonymous to us. All right. Another important thing to point out is the naming conventions and the support that you get from EF Core when you follow certain conventions. So generally speaking, an ID column is going to be called ID. Sometimes you might qualify it and say league ID or the table name ID. Now, EF Core will identify either one of these conventions, and it will automatically infer that this is intended to be your primary key and auto-incrementing SQL identity column, right? So it will automatically see that naming convention and tell SQL that this is the primary key column. So if you veer off the path of that general naming convention, then you're going to have to do additional configurations to get that to work. So to me, it's easier to just work with EF Core than to force EF Core down another path. It's not the hardest thing to do, but why give yourself more work when it can be that easy? So just by saying ID, it will know that this is the primary key and fit up everything else for me. All right. Now I'm going to create the next table, or the next class to represent the next table, which is team. So I'm just adding that to the domain project. Team is the name, and then team, once again, public, will also have ID and name, as we saw, but then it has a third column, which is the league ID. So that represents a foreign key. Now, what we're going to do when we have a foreign key, we have to add two properties. One being the table name, or the name of the table that this is a foreign key to, and ID. Once again, naming convention. The second would be a navigation property, and most times you'll see them making this virtual. Let me just add that. So public virtual league being data type of the table, the class that we just created, right, with the same name. That's fine, but the combination of these will leave EF Core to infer that this name matching the table name and the word ID means that this is a foreign key to that table, right? So if you've had to set up a foreign key in SQL Server, you know that you have to go in and you have to choose the columns and you have to do this and you have to do that, and there are a few steps. This is all it takes. Follow the naming convention and have that navigation property, and EF Core will just say, okay, I know that this is a foreign key, and I know that I can automatically include or automatically present the related details to this record through this property. Later on, we'll see that I don't want to shoot too much information, but I'm just trying to show you that from the get-go, once you follow these fundamental naming conventions, EF Core is going to do a lot of the work for you. So that's actually it for now. We have created the classes that are supposed to represent the tables in the database. So of course, the column names match. The data types are, conceptually the same as what we would expect them to be in the database. And later on, when we come back, we're going to look at how we set up the DB context, the provider, and the actual connection to the database, because none of that exists right now. There's no database. We're just modeling it out and saying, well, these represent what I want to store. So when we come back, we're going to see how we actually set up the LINQ to the database. All right, guys, we're back, and the objective of this lesson is to set up our data class so that it knows that it needs to connect to a database. All right, so our data class, we're going to have to add a few libraries to this to let it actually interact with .NET Framework, with Entity Framework. Because right now, nobody knows anything. We're just talking about Entity Framework. It's named Entity Framework, but it doesn't know anything about Entity Framework. So let me just start off by deleting this default class. And I'm going to jump into the NuGet packages. And let us go to browse, and we're going to be searching for Entity Framework Core SQL Server. So before I go ahead and install that at the jump, let me just explain. You have Microsoft Entity Framework Core. This is the base library for everybody. I think every other variation has a dependency on this one, right? So if you look at it, it's a modern object-based mapper for .NET. It supports LINQ queries, change tracking, and it works with a number of databases: SQL Server, Azure, SQLite, Postgres, and others. So what you realize is that from NuGet, you can actually get different libraries to support the different databases. So in our case, we're using Microsoft SQL Server, right? But if I was to search for Entity Framework Core and just look through the different variations, we see our SQL Server, we see in memory, we see SQLite, you see Postgres, you're going to see MySQL. I'm not going to go through all of them, but the point is that whatever database it is that you have under the hood, there is more than likely a library to support it, and you can get that from NuGet. All right. As I said, today we're only working with SQL Server, so let us go ahead and install that one. So I'm just going to download it, and in doing so, it's going to show you all of the other dependencies that it has, right? But that's fine. We can just go ahead and click OK, accept any license agreements, and let NuGet install it in our project. So now that it is installed in our project, if I look back in the CSproj file, just by clicking the project file for the data project, you'll see here that now we have that package reference installed. Alternatively, you could have also gone ahead and put that a line similar to this. So you could say node package reference include the name of the library, the version that you're interested in, and then just do a build, and it will automatically go and get the dependencies for you. So you could have done that also, but let us just proceed using NuGet. So I can close all of that off, and the next thing on the agenda would be to create what we call the DB context. So I'm going to create another class, and then I'm going to call this class Football League DB, well, Football League context or Football League DB context. We tend to put that in, right? So DB context just means that it is the context or the connection. Let's just say context equals connection. So DB context means DB connection file, so to speak. And then this is just letting you know what database it is. It's not a naming convention per se. That's how I am doing it. I'm just explaining to you why I'm naming it like that. So I'm going to make this public class DB context, and then every DB context is going to inherit from the default DB context coming from EF core. So you have different DB contexts. You have DB context, you have identity DB context if you wanted like user authentication, but for now we'll just stick to the basic DB context, control and dot, and then that will let me know that I need a using statement for entity framework core. Now that that is satisfied, I can now tell it about the tables. All right. So this, remember, this is going to represent the connection to the database. So whatever is in the database needs to be represented here. So we have the models that represent the tables in the database. Now we have the link to the database. We need to let this link know about the tables. So I'm going to say public DB set. And this DB set just means that the set of rows or records or really a table in the database. You are modeled off team, right? And your name is teams. So you can kind of read it like that, just so you understand exactly what you're typing as you go along. Now I have a dependency. I have to add a reference to the domain project here. And so I'm just going to, you could click that, but I've had problems with that before, so I'm just going to go ahead and do it manually. So right click dependencies, add project reference, and then add the domain project. Click OK, and then we can just go ahead and use our using statement. All right, and then I'm just going to duplicate that line and do the same thing for league. So I have the DB set for league, and we're calling it leagues in the database. However, DB set for team objects, and we're calling that teams. All right, so this once again will generate or interact with a table called teams, and anything that is in the teams table will be kind of serialized or converted to our native team class that we have defined. The next thing I want to do is actually let it know about a database, and we need to do what we call a connection string for that. So connection strings generally like in a web application, they would be passed on. So you have the connection string in the web application, and it's passed down through configuration settings into the context. We don't have that luxury right now, so we'll just do it manually. So I'm going to write override. And then the thing is that the DB context, which is our EF core class, comes with a number of functions that we can actually override and do our own thing with. But the one I'm interested in is on configuring. So this means whenever you're configuring the DB context, what do you want me to do? Right? So I'm going to override it. I don't need to override anything on the base or interact with the base, but I am going to tell it that the options builder dot use SQL Server. So you see that is courtesy of our .SQL Server EF core library, right? So use SQL Server, and we're going to put in our connection string right here. So because this is a demo app in the early stages, we're doing all of this, but of course I'm walking you through it so you understand why we're doing it this way. So a connection string comprises a few parts. We're going to say data source is equal to, and then we would specify the server. So we'll be using local DB, which is a local server built into Visual Studio, and you can access local DB databases via the SQL Server Object Explorer, which you can go to view, and there it is. All right. So local DB // and then we're going to say MS SQL local DB. Right, get that spelling right. Just take some time and get it just like how you see it here, even with the parentheses and everything, the double / and all of that. All right, next up we have the initial catalog, and this is basically the name of the database. What are we calling the database? So I'm going to call it Football League _ EF core. All right. So that is our connection string. All right, and with that, we have actually completed setting up the data provider and setting up the link to the database. Now, of course, this database does not yet exist, right? So I've set up a link to something that's not there pretty much. And I've said these tables need to exist in said database, which, like we just said, doesn't exist. So I'm just going to look in the SQL Server Explorer real quickly just to show you that it really does not exist in there. I have a few test databases, and as you can see, it is not there. So when we come back, what we're going to be doing is using EF core to generate this database so that we can start interacting with it. Hey guys, welcome back. So in the last lesson, we had set up our DB context, which, like I said, is our connection to the database. In this lesson, we're going to start looking at migrations, which are our instructions to the database. So our first migration will be to create the database, because a migration will always say what existed, what exists now, what is different. Let me give instructions to make those changes. At this point, there is nothing. So the what is there now is nothing, and then the instructions will generate what should be there, right? So in order to do our migrations, we need another tool from our NuGet packages, and that library is literally tools, right? We need EF core tools. So going over to NuGet, I'm going to go ahead and hit tools and download that one, and that automatically comes with design and some other libraries. But I'm just going to go ahead and let that install. After installing that, I'm going to have to set a project reference between the console app and our data project, because when we run a command to update the database, we have to have it run against the startup project or the main project. And the main project needs to know about the other projects with the, the connection and the DB context and so on. So I'm just going to go ahead and add a project reference to our console app for both of these, because we'll need to be able to access the domain objects. We also need to be able to access the domain, the DB context, right? So I'll just go ahead and add that. And then Now that all of that is done, we can run a migration. So to run migrations using Visual Studio, we want to go to the Package Manager console. So you can go to Tools, NuGet Package Manager, and you see the Package Manager console. All right, I have mine available to me already down here in this panel. And of course, you can move the panels all about. Let me just redock this one. Now, before we start the migrations, I just want us to take a look at the extent of the options available to us. So in this package manager console, I can say get -help and then type in entity framework, and then give that a few seconds, and then it will generate like a nice document showing us all of what is possible through the entity framework. So you see it starts off with that unicorn, and it tells us about the library. It gives us all the commandlets and what they're used for. So the same list that I just pointed out in NuGet, it's available here with documentation. So like I said, we'll be adding a migration, and then we'll have to update the database after every migration. I mentioned earlier that you have code first versus database first. So if you're doing code first, well, that's the add migration update database. If you're doing database first, then you would want to scaffold DB context, which basically says I'm looking at the database and generating the class models based on what I see in the database. So you see that they have quite a few options available to you. You can script the DB context, script out the migrations. If you're still old fashioned, you generate the migration, you want SQL script, you can do all of that using these tools. So let us go ahead. I'm just going to clear this CLS, clear that console, and then I'm going to now add a migration. So the default project, once again, needs to be the executing project in the solution. And I'm going to say add -migration. And then I'm going to give it a name. So the name, typically you want to use a sensible enough name that you or somebody else, well, let's start with somebody else. Somebody else can come along and say, okay, that is what that was a general idea of that migration. You also want to use a sensible name because after you go on vacation and come back, you want to look back at this migration and understand why it was done and what it was for. So don't name the migration X or just something silly. Give it some meaning. So like how there's nothing here, I have no migrations, no database yet, I'm going to call this one initial migration. I also like to camel case my names. When you use spaces, then you have to take extra precautions when you have to, reuse the names and so on. So I just use camel casing. You can use underscores, whatever, but I just don't like spaces inside of these names. So I'm going to go ahead, add that migration. It's going to build the project, and the build was successful, but I have an error. So let's read this error. And in this course, I'm not going to shy away from errors because I know that a lot of people hate the errors that they get in EF Core. Sometimes they're not very clear and it's hard to troubleshoot some of these errors. So I'm not going to shy away from errors. If anything, I'll deliberately conjure some errors so that we can go through them together. But this one is it's simply saying that the startup project, which is the console app, doesn't reference the design project, right? So in other words, I need to install that package in the console app. So an easy way to get that done, of course, you can go to NuGet, but I'm going to try and do it through the project file. So I'm going to create a new item group and give it a package reference to include Microsoft.entityframeworkcore.design, and I'm just setting the version that I know I'm using throughout the rest of the project. So this version may vary based on when you're doing the course. So if you're taking this path, then that's fine. If not, you can always go to NuGet and add the entity framework core.design package like we've done for all the other packages. Now, our next very important step is to make sure that we have our data project selected. So I just did CLS to clear the noise and the errors in the section, but I just want to point out that we need the default project here to be whatever project you have the DB context in. All right, so for us, that's data. So I'm going to go ahead, select data, and then I'm going to just press the up arrow key, which brings me back the add migration initial migration command. Go ahead and try that again. And this time we have our migration created. Now let us take a look at what we got here. We got our folder called migrations, and it has at least one file in there with the name of the migration that we gave it. Notice it has a timestamp on it. We also have this other one that is the context snapshot. So basically at this point in time, this is what the database will look like. And we have our migration file. So let us take some time now to appreciate exactly what is in a migration file. So typically in SQL, you would have written SQL statements, create table, create database, then create table, then you put in all the fields and the constraints. If you're writing a script, if you were using the management studio, you would have been clicking and all of that would have been generated in the background. Well, a migration file is pretty much going to be a representation of all of those actions, but with C# context and built on top of what we call the builder pattern, right? So if you just take a look at it, it looks complicated, but just sit back, take a deep breath and look at it as a developer. You'll notice that everything it is saying to you makes sense, right? The migration builder, okay, that's an object being passed in here. Create table. Name of the table, leagues, right? And then it's automatically going to make sure that it creates. So even though in the DB context, I had suggested, sorry, I'm just trying to say a lot here. I had suggested initially that when we are creating the data, the class models, we start with the ones with the least dependency. Because if we started with team, and team would have a dependency on this navigational property for league, and league didn't exist, then this would have been a little error, right? So it would have been prudent of us to create league. Then league is already there by the time we're creating things that need league. Now, in the DB context, I didn't necessarily follow that order. I just basically randomly listed them. So I didn't necessarily list them in the order that I wanted them to be created, because obviously I would have wanted leagues to be created before teams. However, if you look in the migration, it already went through and saw that leagues has no foreign keys, teams does. So leagues has to be created before teams does. That's pretty much what EF Core just did. So it's creating the leagues table. It's giving it the columns, ID and name. And if you look closely, once again, following name conventions, ID is automatically going to be an int, not nullable. And it is a SQL Server identity column auto incrementing. All of that was generated because we used the word or the name ID for this column. So EF Core inferred that this is what we wanted as our primary key. All right. And then you'll see here where it's saying the column type is string. That's a C# type. But then in the database, we're making it envarchar. All right. Just let that soak in a little. Then we go ahead and add the constraints to actually make this the primary key, which is ID, the ID column. All right. Then it repeats those actions. Migration builder, create table, create teams, create the columns, once again inferring what the primary key is, and then adding league ID as an int. But then it goes a step further with the constraints, where it creates the primary key and it creates the foreign key, which is linking the column league ID to the principal table leagues and the principal column ID. So you see, all of that is inferred when we use our proper naming conventions. There might be times when you have to, go off course, and that's understandable, but don't let it be a case where you're always going to be doing your own thing and fighting against EF Core, and then you end up doing twice as much work when EF Core is more than happy to do all the work for you. So after creating all of that, it goes ahead and creates an index on that foreign key column. All right. Now you'll also notice that there are two methods inside of this migration file. We have up and we have down. Up pretty much means when I am updating the database or upgrading the database, right? This is what I want to be done. Down means that if I am to undo this migration from the database, this is what should be undone. So down, just like how up is the opposite of down, the code that is in up is going to be doing something entirely contrary to the code that is in down. Because there are times when you make a database change and then you say, oh, that's not really what I wanted to do. Then you make a change. But then when you want to make that change, sometimes it's easier said than done. So at least EF Core is saying, well, I am telling the database what to do when the migration is being done. And I'm also going to tell it what not to do or what to do when this migration is being undone. So all of that is automated within this file. All right, so now that we have the migration, we're going to finish off this lesson by running the most magical and probably the most important command of them all, which is to update the database. So up until now, we still don't have our database. We go ahead and type update -database, press enter, let it build. And what that command does is it looks at the migrations that it probably knows about, and then looks at the migrations it doesn't know about, and then just picks up from that point and executes the migrations going forward. So here you see it say applying migration, and then it's telling me which migration it applied. If there were 5, it would have applied 5, but there's only 1. So it's letting me know it has done it successfully. So when I look back in my database list, I will now see the database by the name that I had defined in that connection string, Football League EF Core. When I expand the tables, I'm going to see EF migrations history, which is basically a table in the database keeping track of the migration. So you can tell up to which version your database is, right? And then you have leagues and we have teams. And if you look, you see keys. Okay, so that has a primary key, and then you see here that league ID is a foreign key. So all of that was set up in the database for us courtesy of this migration. Now in the next lesson, we're going to look at how you could have scripted this migration, because you may not necessarily want to run update database and do it like that and let EF Core have complete dominion over everything in the database. But there is a way that we could have generated an SQL script based on these instructions, and then you would be able to execute it on your own. So when we come back, we'll look at that. Hey guys, welcome back. So in this lesson, we're going to talk about scripting our migration. So the case study for why you would want to script as opposed to, generate a migration file and do it from the package manager would be maybe just separation of controls. Maybe there's a database administrator who is in charge of database changes. So you the developer, wouldn't be making these database changes, but you've done the migration against your local. You need to hand it off to him so he can do it in the environment. There are different situations that might determine whether or not you can do it the way that we just did it in the previous video, or you would have to script the migration and hand it off. Nonetheless, we're going to learn how to script the migration, and it's a very simple procedure. So we have only one migration, so the script won't be the most complicated one. As the script grows, there are particular behaviors that get added accordingly, and the script grows with the different migrations. All right, so later on we can revisit that, but right now we just want to see how we would script this migration. So in the package manager console, it's pretty simple. You just say script -migration. Then what it's going to do is the regular build, and then it's going to generate the SQL file that corresponds with all of these commands. And there we go. So you'll see here that it's checking if the migration history table is null, then go ahead and create that table. Then we start the transaction, we create the tables accordingly, we get the index, we insert into the migration history the migration that has just been executed. All right, that's it. So once again, this is probably going to be done when you want to hand off the responsibility of the database changes or database creation, whatever it is, to somebody else in your team, in the organization. And that is what EF Core allows us to. Hey guys, welcome back. In this lesson, we're going to take a look at the EF Core Power Tools and how they can help us to visualize our database through Visual Studio. Now, this is coming off the heels of me showing a database diagram earlier where we were in the SQL Server Management Studio and I generated that diagram 0 just to depict the database that we were trying to build at the time. You might not necessarily have that luxury, and I'm not saying you need to go and get the Management Studio, but using the EF Core Power Tools through Visual Studio, you are able to generate a similar diagram and see how EF Core visualizes your database or whatever database it is connecting to. So let's get started. If you have Visual Studio, that's good. You just go to extensions, you go to manage extensions. And when that dialog comes up, you just search for EF Core Power Tools. And when you see it in the search results, you just go ahead and hit download. After that, we'll need to restart Visual Studio, so you can go ahead and do that quickly. Now, after closing Visual Studio, the extension manager is going to come up and finish the installation. If you don't already have this feature DGML editor installed, which probably was installed with Visual Studio, so you might not have to go through this step. But if you're going through this step, then it's no problem. Just go ahead and hit modify, allow it to bring in the dependencies. And once that procedure is done, you can reopen Visual Studio, and then what we're going to notice is when we right click a project, we're going to see a new menu item in the form of EF Core Power Tools. So you see a number of options, some of them looking just like what we've been discussing up until this point with the different migrations and scaffolding and forward engineering. All of those things are actually possible through these EF Core Power Tools without the need to write the commands. However, for this particular lesson, what I want to focus on is adding the context diagram. So of course, once again, we want to make sure we're in the project that has the DB context. We're going to right click, go to EF Core Power Tools, and then we'll say add DB context diagram. And then it's going to generate a new file with an extension .dgml, and we're going to get our diagram. So I thought I would be able to select, but it's actually just dragging all around. So you see here, it's giving us this DB context in the form of a diagram, giving us the team, the different properties, and we can click or hover over the property to get a bit more information on it. It's the primary key and it's not nullable. You see all of those annotations or all of the metadata is available right here on hover. And if we hover over the table, it's pretty much the same thing. So from Visual Studio, we can use this tool to visualize exactly what is happening in our database at any given point. Now, given that we only have 2 tables right now, this diagram might not seem as exciting as it probably could be. But, you can just take some time to look at it. You can hold on Control and scroll to zoom in a bit, or you can just change the zoom up top here. And you can take a look at the legend where it points out what the different symbols or the different colors are. So you see here, red represents the navigation property. What's that, purple or bluish? I'm sorry, I'm slightly colorblind, but this purplish color represents the foreign keys, and then the primary key is highlighted, and then the different properties are. So you can take some time to just take it in. You can see the different kind of relationships, but as our database grows, we will revisit this and take a look at how EF Core infers what kind of relationships and different annotations on different properties as we go along, and then we can see this diagram evolve with our database. Hey guys, welcome back. So in this lesson, we're going to be setting up EF Core with some additional options to spit out more details about what it's doing. So EF Core is really quiet by default, but we want it to make some noise because when we're executing our commands, I want us to have a visual representation of the SQL that's being orchestrated and the different operations being carried out in the background while we're doing our thing. So what we're going to do here is extend the options builder to know that it needs to log to, And I'm going to let it log to console.writeLine. So because we're using a console app, it's only write. So we log to console.writeLine, and I'm going to add to the configuration, or the, let's say, the pipeline of what it should be logging. I want it to log the db logger category command name so that we can see a visual representation of what exactly is being done. And I'm going to extend that to let it know that we want a log level. So I'm just going to say log level dot information, and I think I'll have to include, there we go, include a library for Microsoft.extensions.logging. I think I got ahead of myself just now. So it's new db logger category, and then we close a curly brace here. Right, and then we have the log level information, then we close the parenthesis there. So just take a look at that line. Apologies for that. So we log to console.writeLine, new array, and then we're just passing in the command name line right there, db logger category database.command.name, and we're letting it know that we want a log level of information. So that means everything it's doing, we want to be seeing spit out to the console. Another thing I'm going to include is enable sensitive data logging. So that enables us to see, or it tells EF Core that everything that is happening in the background that you probably wouldn't want your front-end user to see, we want to see it. It's our app, we're learning, so we can at least do this with zero risk, but you wouldn't necessarily want to do that on a production server, but it does help with debugging in certain situations. So now that we have all of this wired up, I'm going to just jump over to the console app. You don't necessarily have to do this step. I just kind of wrote some code so that we can start interacting with EF Core, so you can see exactly what all of that would amount to. But in the next few videos, we will be going through all of this code together. But for now, I just want you to see a sample of the additional logging. So on screen, you'll see the console application. And if you take a close look, you'll see the logs being spit out. So we have info. At that timestamp, we did this command, and then it's showing you that we executed db command. The parameter was, so what would happen naturally if we didn't enable the sensitive logging is that these parameters, you would not see the values. So enabling sensitive logging, like I said, will show some details that would have been left out for, security reasons, hence the title, sensitive logging, right? So we can see exactly what values are being passed in and the size of the value, the type, the command timeout, and then we see the actual SQL being generated, insert into that table, the values, and then it's just taking that parameter, so it's not putting that value in directly. So that just goes to show that EF Core is actively doing parameterization, which is a key component to the fight against SQL injection as a security loophole that many people try to exploit, right? So it's parameterizing the simple query, and then it just goes ahead and selects the ID from there and updates the scope identity. But right now, I'm not going to get into too many details about what the script is doing. I just want to highlight that we are now in a position that when we're going to be writing our EF Core commands, we can see actively the SQL that is being generated in the background. We also see the runtime. Right, this took 61 milliseconds, but there might be times when maybe a query is running too long and you're wondering why. You probably need to tweak it. All of those things you can do when you have this kind of logging at your disposal. Hey guys, welcome back. So in this lesson, we're going to take a look at how we can perform simple insert and select queries using EF Core. Now, coming off of our previous lesson where we looked at the verbose logging and adding additional information to the console, you'd have seen that I had this bit of code that we are about to explore and try to understand. So the first line that I want to point out to you, and this is once again the program.cs file in our console app, All right, so the first line that I want to point out to you is where I'm instantiating our DB context. So I have private static football league DB context, and just in case you're wondering where that name is coming from, that is the name of our DB context here. So remember that I said that this file represents the connection to the database. It has the connection string, and well, it knows about the elements, or the entities rather, in the database. So this entire class, as our database grows or contracts, this class is what gives us that gateway access into the database and allows us to interact with the different entities. So we have to have an object instantiated of it. Now, in a regular .NET Core, well, let me not say regular .NET Core, in like a bigger .NET Core application, like a web application or even a Blazor application, you wouldn't see it being done this way. You would see it being injected in. But once again, we're here to learn about the syntax of AF Core, so I'm trying not to focus on those other aspects of development in this particular course. All right, so we're instantiating our football league DB context. I'm calling the object context. You would have seen different suggestions given to you, so you can choose whichever one you think is more indicative of what this object needs to represent. But context is almost like the universal word to mean the file that connects me to the database, right? Hence us using it in the name of the class and even the object name. Once again, naming is more subjective, so that's fine if you have other ideas. So we just instantiate it here, and then we move on to the main. So like how we did it in the class, this is global to any other function that we're going to be using inside of this class file. Now, to add something to a table, the syntax would be context. Once again, that object that represents the connection to the database. So we say context dot the table we hope to interact with, and this leagues, this word leagues, is really relating to whatever we called the tables here. All right, so that is leagues. So if I just retype this from scratch, I'm going to say context dot, I'm going to see a bunch of options. I can add a sync, I can do a number of things, but then you'll see the different properties, and some of the properties would include the table names. There's leagues, and if I scroll down a little bit more, there's teams. So as many DB sets as we have defined in the context file, we get to access them directly right here whenever we need to interact with said tables. So context.leagues, and then what do I want to do with the leagues table? In this situation, I want to add. Now, if we take a look at the add function, you'll see here that the overload is expecting the, well, not the overload, the parameter that is expected by the add function rather is of type league, and it's just saying it expects a league entity. So in other words, it expects some object of the type league. So that's the beauty of AF Core. It allows us to stay in C#, because in SQL syntax we would have had to write something like insert into leagues and then values, and then list out the values, and that's if we're not going to specify the columns and then the values. And yeah, that syntax would be, it is purposeful, but having to put it into the C# and then convert it and then do all of that, AF Core is just saying stay in C#. I have the object context, I get the table you want to add, and then you give me the data you want to add. So I added a football league from Jamaica here, but then we can change this and let us try English Premier League. All right, so new league, we're instantiating an object, and then we're passing in the properties, and league really only had ID and name. So because ID is already an auto-incrementing primary key, we don't have to provide a value for the ID. We can access it, sure, but we don't need to provide a value when we're adding. All right, so let us go ahead and run this command and see what happens. So logs here are showing us that it has successfully executed this command. It took 112 milliseconds, and it put in the parameters and everything. And then here is the SQL syntax that was generated. So insert into leagues, then the column names, then the values, and then the value, and then it just updated that object accordingly. Now, another line that I want to point out is line 14, which is the ultimate line that you need to call. No matter what you do, thinking you're interacting with the database, once you are manipulating data, meaning you are adding or you are updating data or deleting data, you have to call save changes, because all this method does, and the like methods for the update and the delete, all they really do is track what changes need to happen, but they're tracking them in memory, right? So for as long as the application is processing this particular operation, it is just tracking it in memory that, okay, I know I need to add this, okay, I need to update this, I need to delete that. But then until you save changes actually says generate the SQL, send to the database and attempt this, and then, well, roll back if anything fails and let the user know what happened. All right, so that's really what the save changes is for. And then we called save changes async, but then there is also the save changes without the async, so that's fine. I'll use it without the async since this is not an asynchronous function. I will just keep it simple. But once you're using asynchronous programming, you can always use the async version of these methods, which of course have to be placed in an asynchronous method. So I just swapped out all of my methods into the async versions, and I changed the main function into an async task. And then because of that, now I have to say await add async, await save changes async. All right. Now, another thing, I just want to break this out a bit more, because right here I am adding the object directly into the parameter. That might not always be the case, because especially in bigger applications, like when a user is submitting the form, then in a web application, they submit the form, you would get all of the data from the form in an object that you need to pass into the database. You wouldn't necessarily want to get it from the form and then have to write new league and then try and put each property with each value again. So you can always just initialize. So I'm just going to say var league is equal to, and then I can initialize a new instance of league. Let me just do this to cut down any long typing. There we go. And then I can give this one La Liga. You can tell I'm a football fan, right? So La Liga. So this would be the Spanish league. Now that I have my object that represents the league that I wish to add to the database, I can now say add async and pass in that object. So it's really that simple. You can build your object elsewhere, then you add it, and then when you save changes, that is when you get it committed to the database. Now, what I want to point out to you also is that once we save changes, this object is going to automatically get updated with its new value. So let me add a breakpoint and run. And what I'm going to do here is initiate a watch window, and I'm putting the league object there so we can track its values as we step line by line. All right, let me just pin this, make it a little bigger so we can see it. So first line, nothing has happened yet. League is null. Then I'm going to step, and then you would see now league has an ID of 0 and the value La Liga. And then it's going to save the changes. And then we step one more time, and if you look at the object, you'll see it now has the ID value. So this comes in handy when you have operations that are chained, right? Because you might have an operation where you need to add something to the database, and then you need that value, that new ID value, in order to maybe display the details of this record on the next page. So I submit a form, you add it to the database, then you bring me to the page to see the data I just submitted, but it's reading from the database. Well, this is where that comes in handy, because then I can query the database directly on that record ID right after the operation has completed. So I'm just going to press F5 to continue with the execution. And once again, we see our very friendly message here saying that it has added that data to the database. Now, just for depiction's sake, as I said, we want to see some of the errors that we might get. What I'm going to do is try to add an ID value to this object before it gets added to the database. So I know that the ID just now was 7, so I'm going to put in an ID. It really doesn't matter what value, because if anything other than 0, when it goes to the add operation, it's going to give an error. So I just want us to see the kind of feedback that we're going to be getting from EF Core. All right, so just running it and allowing it to do what it needs to do. And then you see here, it is failing and we're getting this error here. It is saying an error occurred. SQL exception cannot insert explicit value for identity column when identity insert is set off. So you see, we're getting literally one of those errors that we would have seen if we tried to do this in SQL directly. If it's not the same error, then it is worded very similarly to it. All right, so that's the kind of feedback that EF Core will give us whenever we try that. And we'll see here in our console log that it just failed. It just tells you failed, and insert into that just failed. All right, so if I continue, then the execution will end accordingly. All right, so we're winding down now, and I just want to do one more example of how Entity Framework Core can make life easier. So in this situation, I want to add a new league, and we're calling this one Serie A. That's the Italian league. And we add the league like we know we have to do, then we save changes. But then I need information from this league in order to conduct another operation. In this situation, I want to add teams. So obviously a team needs to exist in a league, right? So I need the information from the league that was just created in order to create these teams. So what I'm going to be doing is passing this league object over to this method. And then notice that we'll have to save changes, because every time we're carrying out some operation against the context, we have to save changes in order for it to take effect in the database. So I already created that method. I made a static async task, and I called it add teams with league ID. Well, I called it with league ID. Let me just take off league. Let me take off the ID, because I am showing two different operations in this example, and you'll see why. And it's taking a parameter of type league, which is the league. All right, so you can just go ahead and replicate that. And then in this method, I am trying something different. Instead of one object to then add, I am doing a list of objects, and then I'm going to add range. So this is now going to take advantage of EF Core's ability to do bulk operations. Now, a little tidbit about bulk operations. It is a feature that allows EF Core to kind of batch multiple like add operations and so on into one SQL statement and shoot out. But then the team kind of decided that, well, it would be more efficient at smaller numbers of records to just do individual SQL statements. However, at a certain threshold, you'll start seeing one SQL statement with all the information. So that's just a little bit about how these bulk operations work in the background. But in this method, what I'm doing is defining a list of teams, right? And each one, I'm giving its name. So this is Juventus, and this league ID is the ID coming over from our league object, right? And then the next team would be AC Milan, following the same format. But then the third one, which is AS Roma, I'm doing something different. Instead of using the foreign key, I am now using the actual navigation object and reusing the object that has been passed in. So we're going to see exactly how that works. So these would be the traditional way. You have the foreign key, you put in the foreign key value, and it's satisfied, right? But then in this team, instead of using the foreign key, I'm using the actual object to pass in. So let us see what this would do. So I'm going to put a breakpoint at the first save changes, and then we can just step through and see the operation step by step. So I've added the watch for the teams also. All right, so let me just step through. The league hasn't been created as yet. So step, I use F10 so I don't have to go over to the context. And now we have our ID of 8. If we look in our league object, we see it updated accordingly. Then I'm going to use F11 to go into this method. where teams is now defined. So I'm just going to step through its creation. And then if I look in the list of teams, I see I have all of them with their respective IDs. And then AS Roma is here with the actual navigation object instead of the league ID. All right, so league ID for AS Roma is 0, but then league ID for everybody else is 8 as expected. However, the navigation property for everyone else is null, and for AS Roma, it has its navigation property. Now, let us see what happens after we save changes. I'm just going to press F5 so we can see the logs that get spit out, and you see the first insert operation happening right here with the league. Oh no, this one is with the league, sorry, right? Then we see another one happening for the first team, and we see that the ID, the league ID of 8 and the name that's being passed in, league ID, name, right? And then for the last one, you notice that it's the same SQL statement. It gets the 8, it knows it's AS Roma, and it does the same kind of insert. So that's just going to show you that you can put in the actual foreign key value, and it will, of course, do what it needs to do with the insert. Or you could put in that whole object, and it will still infer that, well, the object has its primary key. So obviously, this is a related object. So the foreign key would be the primary key of said object, and whatever other data, right? So EF Core is doing that for you in the background. So I just wanted to highlight the different ways that you can insert a record that has a foreign key dependency. Now, there are a few other things that you can do, but sometimes they only come with experience. But at least if you understand the basics of how to add something to the database, and notice I had to add here, save changes, and then add again and save changes, because I needed this to be added for the key to be generated so that I could carry out this operation. All right. On the flip side, if I had done something like this, and just take the time to look at it, I just kind of reworked it so you didn't have to sit and watch me type. But what I'm doing is still initializing a new league, and then I have a team. This new team has the name Bayern Munich, and then I'm passing in this league object. Now note, I'm not doing any add, I'm not saving changes in between these two lines, right? So fresh league, fresh team, and it's getting that fresh league object. And then all I'm doing is adding the team and saving changes. And notice the difference between this add and the previous add async lines. You have the option, of course, to highlight the table that you wish to interact with. So if I said context.leagues add async and then passed in a team object, it's going to be an automatic error. Why? Because once again, the add operation requires a type of league, right? So I can't be passing in a team object. I could, of course, have said .teams and everything would be okay. But then if I didn't specify the table, Entity Framework Core would automatically know that, okay, this is a team object, or it's a list of team objects like we did down here, where I just said context.addRange passed in the list of team. So it knows that clearly it's going to look for the corresponding table for that data type. So you don't necessarily have to, at least when dealing with the context, you don't have to specify the table all the time. All right. But what I want to point out is that when I do this and then do one save changes, it's actually going to create the dependent property and then automatically create the team with that foreign key. So let's take a look at that operation. So when you look at what it generated, you'll see that it executed the command to create the league first. There it is, creating the Bundesliga. And then it gets that ID. And then it goes ahead and executes the one to create the team, passing in the new foreign key into that new team. So you see EF Core is just pulling all of these strings for you, all because I told it I want a new team, and this team is a part of a league that I don't know the ID of. So it said, no problem, I have this. It goes ahead, creates the league, gets the ID, creates the team, and then just lets you know everything is done. So if you took a look at that team object, you would see all the data relating to the team and the league. So when we come back, we'll start looking at doing some select queries, because up until now, we've only been putting in data, putting in data, putting in data. Now let's look at how we can read the data from the database and display it in our application. Hey guys, in this lesson, we're going to be talking about simple select operations. Now, before I move on, I just want to point out that we did quite a bit from the simple insert stuff, and I have extracted them into individual methods. So I've got rid of the code and I've kind of commented them so that when you look back at it, you can see what is happening where. All right, so I just have them commented out because we don't want to keep on adding and adding and adding the same old data. So now it's time for us to look at selecting. So I'm just going to park them, put them to the side, and then we can continue to work around them. All right. So when we talk about selecting, this would be the R in CRUD. So I don't know if I use that acronym prior to speaking on this topic, but CRUD, create, read, update, delete. All right, that's an acronym that is widely used in database development, and it represents basically the 4 operations that you'll always carry out on a database in any application. You're creating data, which is what we just looked at when we look at inserting, that's creating. You are going to read data, meaning you want to retrieve the data that is in the database. That's what we'll be doing now. And then later on, we'll look at the U and the D, which stand for update and delete. Now, when we want to retrieve data from our database, we start thinking about formulating what we call LINQ queries or LINQ statements. So LINQ, which is short for language integrated query, right? So it's basically like a dialect. I call it a dialect of C#, right? It's a way that allows you to write a query using C#, and then of course core is going to translate that into SQL. So let's get started. The first and simplest thing that you can do, the simplest LINQ query to retrieve data from the database would be and I'm just going to define a variable. So I want all the leagues to come back, and I'm going to say var leagues is equal to context, which is connection to the database, dot table I'm interested in, which is leagues. And just this is telling it that, okay, look in the DB set of leagues, but then I want it in a list. So I'm going to say dot to list. And then it's going to ask me to include a certain library. So I'm just going to control dot, and you see it's telling me that I need the library system.link in order to do this. All right, so I'm just going to go ahead and include that. That error goes away. And just like that, I have told it select star from table called leagues. That's pretty much it, right? So then what's going to happen is that context creates connection to the database. It goes to the leagues table, and then this to list just says extract the data, bring it back in a tabular form, but then materialize them into a list of league objects. So just the same way that we had created the list of teams, where is it? Here's my list of teams, right? The same way we created the list of teams, it's the same way it's going to materialize this into the list of leagues for us. So what I'm going to do is do a for each, and I'm going to say for each league in leagues, I want to console.writeLine. So I'm just using a hyphen to separate the ID from the name. All right, so let us take a look at that. All right, and when we look at the output, we see here the statement that was executed, select ID and name from leagues as L, right? So that's basically that SQL statement, which you could just copy from the console, go over to your management studio and execute. So that's comes in really handy when you're troubleshooting. Maybe you wrote a query and you're not getting back the results you want. You can always get that SQL statement and try and decrypt why this SQL is being malformed. Once again, that's a very powerful tool. However, when we take a look at the objects being printed out, we see everything that is in the database. So while testing, we probably entered the Red Stripe Premier League a few too many times, also the Premier League, but then we see all the other leagues as well. So that is what we get when we just simply say context dot table name dot give me them as a list. Now, some important things to note when it comes to this syntax. This is what we call the executing statement. So without this, that query wouldn't be run. This would just say, well, leagues is now just the hash set or the DB set of the table called leagues, right? So when we put on the to list, that's when it actually says, I will go and execute that query and enumerate them and send them back as objects. So if we were supposed to do something like leave off the to list and then still execute this query would not get executed until it actually starts the for each loop. So it would just be like in a state of stasis here. And then when we start to for each through, then it would say, okay, let me go and get them so I can enumerate through. Now, the danger of doing it this way is that the connection will remain open for the duration of this for each loop. Now, with only maybe 15 records, that doesn't seem like much of a big deal. I mean, okay, fine. But then when you're going through a bigger database, you have that connection open. And let's just think of every connection to the database as an expensive operation in any system, right? So you want to reduce that as much as possible. And you also don't want a connection to be open for too long or longer than it needs to be. So when we do the statement like this, and we could even get rid of that leagues part of it and just say for each var league in context.leagues, the point is that this would actually kind of create a lock and a very inefficient one at that. As a matter of fact, the more operations you have doing in that for each, the time between going through each item increases, and then of course the connection stays open and it becomes even more expensive. So I'm just pointing that out. Yes, you might try this and it works, but it is not the most efficient way to do it. The most efficient way and the smartest way to do this, once again, would be to put on that executing operation, let it iterate through and get the list, and then that list is now stored in memory. That connection is now close to the database, and then you can do all of your operations and manipulations against the data afterward. All right, so that's really it for doing the simple select queries. I've kind of extracted all of that code and put it in this method, which is a static void method. So this one doesn't use any asynchronous operation, so we don't need to make it an async task, right? So it's a simple void. And what I've done is to highlight which one is good and which one is pretty much bad. All right, so not everything that works, even though it works, it has some underlying ramifications that you might not be aware of, but that's why I'm here to kind of point out what is the best way to kind of go about your operations. Hey guys, welcome back. In this lesson, we'll start looking at how we can filter our queries. Now, the case study for filtering is obvious, right? What we've looked at in the simple select is that we are selecting all and then we're iterating through all. There are situations where you don't want all, you want specific records, and that's what we'll be looking at first. So I've created a method, query filters, and before I move forward, I want to highlight that I did say that we made this one void because nothing asynchronous was happening in this method. Well, thanks to Entity Framework Core, we do have to list async. And when I control dot, I just have to add that using statement for Entity Framework Core. And then thanks to that, I can now make this asynchronous as well as add the await before the async call. All right, so let us move on now to our query filters. So when we want to add a query filter, and I'm going to say var leagues, all right, is equal to our context dot the table we're interested in, which is leagues, then dot, and I have access to a number of methods on this side. So if I wanted to say, give me all the leagues where the name is equal to some value, then I can say dot where, and then this where function takes a parameter that looks like a predicate, or it is a predicate or a lambda expression. So the format for a lambda expression is you have some token. I'm going to call it Q. Most examples on the internet, you'll see them use Q. However, there is no stipulation as to what this token must be. Of course, just treat it like a variable name. So if you want to use Q, if you want to use league, you know, whatever it is. So if I said Q and then it's followed by this lambda arrow, then I can now use Q to represent any one record in the table. So that's the format of a lambda expression. So if I used X, right, it's the same thing. If I wrote out the word league, I'm just highlighting that it doesn't really matter what you call it, they all will function just the same way. So maybe this one would, you know, read better because once again, it's saying database, give me the table called leagues and give me the records where any one league has a name that is equivalent to some value. So if we wanted to find, say, Serie A, then that's what that would kind of look like, right? Once again, this token could have been Q, it could have been X, it could have been Y, it could have been Z, right? So it doesn't really matter what you use as that token. Now, if I do this, it will not execute until, once again, we end it with our toList. And since we have the async version of the toList, we can say toList async, and then I'm going to await that, and of course make the method an async task. All right. And then after doing all of that, I'm going to repeat this operation where I'm just going to print them all out to the console and await this function call, and of course an await goes before everything else. I'm just going to fix these things before I move forward. So when we call that, it's going to go ahead, look in the table where that condition is met. So this is going to be true or false. So it's either meeting the condition or not. If it has met the condition, it will be added to the list and eventually returned here. So let us run this query and see what we get. All right, and then we see it is coming back. We have our one record coming back. If we take a look at the SQL, we see it's just a simple select query, but it adds on that where clause with that condition. All right, now I hard coded. Notice that unlike the other times when you saw the parameters, it actually just put the actual value inside of the query, and that's because it was kind of hard coded. So I did mention that parameterization is a good protection against SQL injection. So the reason EF Core has not used parameterization in this situation is that it sees that I am the one who hard coded the value from the code. So I wouldn't put in a SQL injection directly into my own code. So EF Core is like, okay, it's safe because my master is the one who did this, so it must be fine, right? But then the reality is that in normal situations, you'd probably be getting whatever it is you're searching for from somewhere else, right? So let us get a bit creative here. So I'm going to tweak this function a bit, and I'm going to say console.writeLine enter league name. So I'm prompting the user this time. So once again, this is a console app, but in a web application or so on, usually you allow the user to depict or determine what it is that they need, right? And you carry out the filtering accordingly. So I'm prompting the user, and then we're going to store the response in this variable. And then that is the variable that I'm going to use to execute the query. So I'm going to say where the lambda expression q.name is equivalent to league name. All right. We could also even say dot equals, because we could just rely on the C# functions that we probably would use in a regular if statement. But you notice that that looks just like an if statement, right? It's the same kind of logical operator that you would use in a condition, because once again, this is just a condition that needs to be true, or well, it needs to be true in order to be included in the list, right? So now we kind of boasted it. Now we get to interact with it a bit more. So I'm going to run this, and we're going to see the prompt. So I've already entered Serie A. I press enter, and then it took 83 milliseconds to go out, and look at it now. It parameterized league name, and then it is executing with the parameter. So you see, once again, this is automatically kind of safeguarding against SQL injection through the parameterization, right? And we're getting back our Serie A. Now we only have one one league with that name, but we did have multiple Red Stripe Premier Leagues. So I'm going to try this again with something that I know is going to return multiple records. So we're trying again with Red Stripe Premier League, and the filtering will now bring back all of the records. So you see, it is working, right? It's bringing back every single one that has that exact name. And remember that this time we didn't use the double equal sign. We used the C# because this is a string. So we said dot equals league name. So it allows us to kind of write that C# syntax that we are familiar with in other parts of our code right into the query, and it just handles all of the rest for us. Now let us do one more experiment here. There are situations where your filter might not be as exact as a true or false. It might be a kind of fuzzy logic where you want to know if it contains, especially when we're dealing with words, right? So in a typical search, you would be able to type in a part of the word or part of the expression you're looking for, and then you would see matching results. So I've extended the prompt to say enter league name or part of, and then what we're going to do is do two queries. So I'm going to take all of this and duplicate it. And what I'm going to do is called one exact matches and the other one partial matches. So for the partial matches, I'm not going to say dot equals, but I'm going to say dot contains. All right, because in C#, if we were to try to figure out if a string has another string in it, we would say dot contains. So that is what I'm going to pass over in this where expression. So let us take a look at this. So I'm just going to use one, I'm going to enter one bit of string to search for. So I'm going to enter Premier, right? I know I don't have any league that is an exact match for Premier. So we already saw the exact matches work, but I'm just going to type in Premier. And then what you're going to notice is that it's going to execute both queries. So it's going to say executed. This is looking for Premier. So this one has the where clause for the league name Premier. Of course, there are none, but then this one has the where league name like n or char index l.name is greater than 0. So it just charred out a whole nice query to say I'm looking for something like what is in the parameter. All right. And then that is when we see all of our leagues that have the word Premier coming back. All right. So that's another way that you can go about filtering your queries. Now, when it comes to the like, you can use the contains, or you can use EF functions. So I'm just going to duplicate this and I'll comment that part out. So that's option 1. Another option would be to use the EF function. So I still need the lambda token, still need to initialize this, but I'm going to say EF dot functions dot, and then you see here I can do contains, I can do like, and a bunch of other functions that would be available to me if I was doing straight SQL. Some of them are right here for access for us. All right, so I'm going to do the like because that is more like what we're looking for. So I'm going to say like, and then I'm going to say q.name. So the like method takes what is the expression or what is the string, what is the database column that I am comparing on, and then the second parameter would be the string pattern. So if I wanted to put in a specific pattern, if you're familiar with SQL already, then you know that when you're dealing with like, you have that wildcard. So I could say Premier a modulus, which means it starts with the word Premier. If we put the modulus in front, it ends with the word Premier. So whatever you would have done in SQL for that modulus, for that wildcard bit, you can do it inside of the string and it will just aggregate it and create that like expression exactly like what we would expect. So in our situation, because we're dealing with this variable, I have to get a bit more fancy. I don't want to hard code what we're looking for. So I'm just going to use some interpolation here, and I'm just going to put in the value that is coming in from the input. So we're saying, get me all the leagues where the name is like this search pattern. All right, so let me just do that one more time so we can see what that will spit out. This time I'm going to type in La. I don't know. I don't have La Liga. I don't know which other league in the database might have the letters LA in it. But we see La Liga being returned. And if we look at that query once again, we see that it is giving us the format, and then it's saying where the name is like that parameter. So you see that kind of looks a bit cleaner than what the contains query generated, but at the end of the day, they're both going to give us very similar, if not the same, results. So that's it for a little experiment with filtering our queries. When we come back, we'll look at how we can go about aggregating data. Maybe we want the first one in the list, the last one in the list. We want the sum of everything in the list, those kinds of things. So when we come back, we'll take a look at that. Hey guys, welcome back. So the objective of this lesson is to understand or have an appreciation for some of the other methods that we have available to us via LINQ and EF Core and how they work exactly. So I've already gone ahead and created a new method, and this is for additional execution methods. So I have a statement here that looks just like a select statement coming from our previous activities where we have context.leagues where, and I'm just saying contains A. Now the case study for an aggregate function or one of these additional execution methods would be that you probably don't want the whole list. Probably you want something done against the list, or you want to cherry pick the list. So when we talk about aggregate functions in SQL, we talk about things like min, max, count, sum, those kinds of operations. All of those are available to us through these additional aggregate functions. Now, another thing that you'd probably want to do is get the first or the last in a list, those kinds of things, right? So I'm just going to use this as a quick example. And what if I wanted the very first league that has the letter A in its name? Then after saying all of this statement and adding the filter, I would then end it with a first or default. So you'll see here that we have, of course, the async methods, and for every async, there's a non-async version, right? But it's not necessarily the other way around. So not every method has an async counterpart, but you'll see that later on. So here I can say I want the first or default, or I can say the first. So the difference between first and first or default is that first will always expect to see a list and it will get the first. So if nothing is returned, then it will throw an exception. It will end the execution with an error. All right. First or default, however, will say I will attempt to get the first, and if there is nothing to get, then I will return null without ending the execution at that point. All right, so first or default is probably a safer bet, and then what that will do is just get back the one league that is at the top of the list. All right, now we could actually simplify this, because what we're doing here is saying give me the where clause and then put in the condition and then get me the first. I could have actually just done this. I could have said context.leagues dot first or default this condition. So that is an executing method. So remember, going all the way back to our simple select, saying context.league doesn't really do anything, but then once we put on that method, it executes. We saw the same thing with the toList and the where, but in this situation, I can just say first or default, and then that condition, and then it will execute the query accordingly. So I'm just going to kind of break out and show you some other commonly used execution methods. So I'm going to replace that line with a simple statement that is getting our DB set here, right? And of course, from we have the DB set, we can access all of the execution methods. So let's just go through them kind of in order. So we already looked at the toList. We know that the to-list is going to execute the select star statement. We also have first and first star default, and we just discussed the difference between the two of them. So we can say leagues dot first async or first or default async. And once again, they do have non-asynchronous versions to these methods, right? So based on your situation, you may be using the async, you may not be using the async, but I'll just keep it kind of consistent and stay with the async. We also have the single or default. So single, it kind of does what the first would do, except first is seeing a list and it's just going to pick the first, literally the first from the list. Single is going to operate similar to the first, where if it is looking for one. All right. So first is expecting a list and it's going to take the first. If no list is returned, then this throws an error. Single is expecting only one record to be returned. So whatever query you write is expecting only one record to be returned. If it sees more than one, it will also throw an exception. Single will just not throw the exception but return default under similar circumstances. All right. And you can always read up more when you just hover over the method. It will kind of give you some education as to what it does. Now, when it comes to some of the traditional aggregate functions that we would probably know from SQL, you'll see you have count. So you can say leagues.count async, it will execute the count query. You have long count, you have minimum, you have maximum, you have sum, you have a number of other ones. Like I said, you can always just say leagues dot or context dot table dot, and then you can scroll through and you'll see the plethora of methods available to you. You can choose to use them when you need to use them, but sitting down and trying to go through all of them at once might be exhausting. But at any point you think you have an idea in mind, you can always just do the dot, control space, and just look through and see which one of these meets your need at that point in time. Now, another execution method, which is not necessarily a query method like one of these, but it will execute against a DB set, is to find async. So this one will actually just go out and find based on a value. So that value is going to be the key value, right? So it finds an entity with a given primary key. So when you say find async, you're expected to put in whatever unique identifier is there for that table, and then it will bring back that record. It will either bring it back or bring back null, right? Or it will return the record or return null. So that is how that find async works. So let us try executing and see exactly how this would work out for us. So I've set a breakpoint at the start of this method, and I'm just going to go through step by step so we can see the SQL being generated. I believe when it gets to the single and singular default, or at least the first, well, it will probably throw an error on one of these, but let us step through and see exactly what is happening. So I've put my windows side by side so we can see every step of the way. So when we say to list, it will go ahead and execute that one. And then we see here that we're getting that select query that we're familiar with already. So I'm going to go and do the first. So you see it's getting the first, it's select top one from league. All right, so that's what the first does. And then first or default, if I'm not mistaken, will generate pretty much the same SQL as the first. But like I said, if first doesn't see anything, then it will throw an exception. Now, single is definitely going to throw an exception because it is only expecting one record, but it's getting the list and saying it wants single. So when we step with that one, then it throws that exception. There we go. So the exception is that sequence contains more than one element because it was expecting only one element to be returned. All right. So I'm just going to kill that execution and I'm going to comment out that line just so that we can continue with the rest of the execution. So I continued the execution against all the other methods, and you'll see to the right, some of them were successful, some were not. So single, singular, default, and pretty much all of these math ones threw errors Really, because, well, I'm not really doing anything mathematical here. I have to make sure that I am finding the min of something, finding the max of something. Obviously, that's not really happening when I just say leagues, right? But the point is that these are some additional methods that you can use when you're doing your more complex operations. And if you look to the right, you'll see that up to the count, when we ask for we ask for count and we ask for long count, the difference between the two was that we had select count star for the count and then select count big star for the long count. The only material difference really is that count returns an integer and this one returns a big integer. So, based on the size of the database, you may never end up using long count or big count big in SQL, but the method is there regardless. So that is really it for the execution methods. As we go along, we might find use for them and we may need to interact with them otherwise, but right now we don't. I'm going to comment out all of those that probably gave errors, and I just want us to see the SQL that gets generated when we try to find. So we see here the execution for the find is that it finds the top one where that condition is met. So all of that, once again, is generated for us. And more than likely, we're not going to hard code that ID anyway. That ID would be coming from somewhere, like when somebody clicks on edit in your user interface, you have to know what record they intend to edit. You have to go and find that record, return it, and then present it to the user. So that's a case study for when you'd use that find. So that's it for us looking at additional execution methods. As you saw, there's a much longer list than what we have gone through here, but you have these for reference, and I'm sure you'll find good use for them in the future. Hey guys, welcome back. In this lesson, we're going to be looking at alternative LINQ syntax. So up until now, we've been looking at LINQ in the form of these execution methods and different lambda expressions that we can place in some of them to kind of get our operations unique to our needs. Now, that is fine. Using the lambda expression method is perfectly fine, and as you can see, it can be written in one line, nice and clean. However, there is an alternative syntax that some developers may find a bit more intuitive because it looks a bit more similar to traditional SQL, but it is still C#. So this is actually the first way that I used to write LINQ before I discovered or got comfortable enough with lambda expressions. And I have the code prepared here for you, so I'm just going to walk you through it. So this time we're looking at the teams, right? And then our syntax here is saying from some token. So this could be, we used Q in our lambda expressions. This I represents something just like that. Q, we could say team, we could say Q. I'm saying I. All right, so from I in, and then we say the table that we're interested in looking in. So context.teams, then select I. So like I said, it looks a bit more like SQL because it actually has some of those SQL keywords, right? It's just a little bit backwards because it would have been select star from table. In this one, it's from record in table select record, or we could say select something specific, but we'll look at that later on. So when I do this query, it is going to give me iQueryable of teams, right? So that means I need to convert that into a list. But let us execute and see what we get, and then we can refine as we go along. Now, if you look at that, it actually executed this query quite perfectly, right? It gave us our select statement, and it's giving us back our teams. So we didn't have to explicitly say to list and try to convert it. Now, one of the benefits, however, of having it as a list is that when it is in the form of iQueryable, our ability to manipulate it to a certain extent is limited, right? So if I looked at teams, there are certain functions here that are unique to iQueryable, and there are certain functions that are unique to lists that you probably would want to use later on in your coding that you can't really get when you're dealing with an iQueryable. So from time to time, I actually just wrap this all and in parentheses and then say to list, and then that just gives me back my list, which is a bit more native to what I would want to be doing in my C# code at the end of the day. Of course, to do that, I have to change my method from void to async task, right? So then we're getting our list, and as you can see, the list, the collection types work fairly similarly, but like I said, there are certain things that the list affords us that an iQueryable, iNumerable, and the other type of list collections or collection types in C#, they just don't. But of course, everybody's situation is different. Use the one that is appropriate to your context. Now let us extend this. We also looked at querying, or sorry, we also looked at filtering our query. So right now this is just doing a standard select star, right? But what if we wanted a where clause? Well, we would say from I in table, and I'm just going to break the line here so it looks a bit more readable. Where, and you'll see that it kind of highlights those keywords for us. So where I, which represents our expression or any one record in the database. So I can say where I name is equivalent to, and then put in my record. So the same way that we were able to inject in our, a variable or a static name or any of those things, we can do all of that right here. Let me see if this would even work. I'm going to try to say where I name, or let me say where EF functions like, and then this would be I.name, and then we have the league name, which I'm just going to do a quick prompt in this method for also, but this would be team name. So enter team name. Let me just change the variable name. And there we go. So we're prompting for the team name and or part of, and then we're saying from the teams table where if dot functions like I.name, right, or expression, and then we want to select I, and then we want to put all of that in a list to return to our variable called teams. So this is going to work, of course. I'm just highlighting the fact that we can use the alternative syntax in the very same way that we use our lambda expression. So here I'm testing it and I'm typing in BAY as the part of the team name. We see our select statement with the like statement being generated for us, and we're getting back Bayern Munich since it's the only team that we have that has BAY in it. So once again, this is our alternative syntax. Whatever you can do in the lambda expression, you can also do in this kind of syntax. Personally, however, I find the lambda expressions to just be a bit easier. So ever since I got comfortable with them, I actually abandoned writing my queries like this. I haven't written queries like this in years, to be honest, but it's good to have the knowledge of all of your options and alternatives if needs be. Hey guys, welcome back. In this lesson, we're going to look at performing an update operation. Now, the general workflow for an update would be that you retrieve the record that you intend to modify, then you make the modification, and then you save the changes. So that's a typical workflow. In any application that you use, that is what is happening behind the scenes. You indicate you want to edit a record, it goes and finds that record, presents it to you, make your changes, and then when you click save, you would have made the record changes, and then the save would commit those changes to the database. All right, so let us first look at retrieving the record. So what if we wanted to modify, and we have some, let me just go and look at our leagues. We have some duplicate values in here. I think we have 3 Red Stripe Football League records, and yes, we do. So we have IDs 2, 3, and 4 being the same. So what I'm going to do is just change the names on some of these, right? So I'm going to change the name of 3. It's a duplicate, but then in retrospect, we realize, oh, that really should have been the Scottish Premiership, right? So we know that we want to modify record with ID 3. So what I'm going to do to retrieve the record is say var league is equal to context dot leagues dot find, and I'll just use async. Of course, if I'm using async, I have to transform my method into an async task and then await it here. All right. So we're going to say find async, and then remember that all we have to pass in is the primary key. So we know we want record with the ID 3. Now, when we get that league, the change I want to make is league dot name. I want that name to now be Scottish Premiership. Then we save our changes. So we already looked at the save changes from when we were inserting. It's the same save changes. Anytime you are going to augment data in the database, you have to call this to commit the command. Then I want to print out the result of this, or I want to print back to screen this record. So I'm just going to create a method called getRecord, which is specifically just to go and find this record. So I have it defined up top here, where I'm just going to say var league, go and find the same record. So after the save changes, then it would have closed the connection to the database. So I'm just going to await get record, which is just going to go and retrieve the record and then print it back to the screen just to show that the update procedure was successful. So let us give that one a go. So when I execute, we see here that it is doing the select. That's where it is doing the find. So it retrieves the record, and then it is carrying out that update. So it retains the primary key and the new value for this record. And then it carries out that update statement. I'll set the name to be whatever value is in that parameter, where the ID is in that parameter. And then it goes ahead and updates. And then, of course, our get record is just reopening that select query, that's a select query, and giving us back that record. All right, so let us try that again. And I'm not going to change anything. I'm going to leave the same record. I'm going to make the same change, and everything is going to remain the same. And then let's see what happens. This time, we don't have an update statement. Take note of that, right? We don't have an update statement because it notices that whatever change I'm making, it's not really a change. That is the value in the database already. So it's not going to bother to waste its time to say, oh, I need to make a change. So you see, of course, intelligently choosing not to open a connection to the database and carry out a command that it realizes it doesn't need to. Now, what enables this kind of change to happen, meaning that EF Core is seeing that the data that we're presenting for that field is different, so then it knows to save changes. This is called tracking, right? We'll look at tracking and no tracking later on, but just as a quick preview, whenever it is that we are modifying objects, EF Core is actually tracking in the memory what objects it has, if there are any changes made to them, so that when we say save changes, it will literally say, okay, I can see a change was made here, I have to commit this change, etc., etc. So that is what tracking allows us to do. Now, there are other things that are other ways that we can carry out an update, because an update may never be as straightforward as finding that exact value and just changing one property and then just saving changes. A lot of the times when people, especially who have user interfaces and they're interacting with a form, when we allow them to edit the data, we don't know what has changed. So we can't for sure know that, okay, we're only going to update name and we're only going to update this and that. We don't know if maybe in editing a team, they change the league and the name. We don't know. So for this other example, I'm going to use teams. So I renamed our method from update record to simple update league record. So it's clear that we're dealing with the league and it was a simple update. And then now we have simple update team record. So let us take a look at the alternative. Now, in the case where somebody using a web interface would have submitted the form, that means that we already have all the information about the record that we need at that point in time, meaning we don't have to go and find it before the update because we already found it before showing it to the user. Now the user has submitted, we have the new data. All right, so I'm going to simulate this by creating a brand new, an object of type team. All right. And then what I'm going to do is specify an ID this time. So up until now, we haven't really given any of our objects any IDs because those are auto incrementing. However, what we need to realize is that when an ID is present, EF-Core is going to look through the database tables for the record with that ID. So I'm going to go over to the teams table, and what I'm going to do is manually insert, just so we can get through this activity, team that is local. It is in the Red Stripe Premier League, but I'm going to put it in with a few spelling errors, right? It's Tivoli, this is Tivoli, and I'm going to put it in with the wrong league ID because it is not in League 8, and based on the teams in League 8, we can surmise that Serie A. It's not in Serie A, so we have to do that kind of update, right? So let us say that this was erroneously entered by some user, and then another user picks up on that error and they are setting out to right that wrong. So they would have been presented with the form, and then they put in the corrections, and then they submitted the form. So the object that they would have submitted would look something like this, where the ID is 7. That is the ID for this team. Yes. And the name, having been corrected, is Tivoli Gardens FC with an O instead of AW. That's the correct spelling. And then the league ID would now be the Red Stripe Premier League, right? So let's use league ID 2. We see that we have another duplicate, but that's fine. Let's just use league with the ID 2. So this is the update that this user is submitting. Now, how do we get this new record into the database? Well, we can say context dot teams, we're dealing with teams, dot update. So we have an update method, which, just like the add, is going to take an object of the data type that corresponds with the table. So we have our team object, and note there's no asynchronous version of this. We have the single and we have the batch version, and we already looked at the batch. The range means if we have a bunch of them to update, we just hand it the list and it will deal with all of them for us. Right now we're just looking at the single, and then after that we have to call our context.save changes, and we'll use the async for that one. All right, and of course I have to make this async, and then all our problems are solved. So let us take a look at what gets done when we pass in this kind of update. So you'll see that it is a similar kind of operation. Now, one, it does an update once again because it sees the ID, right? So it knows that there's a team with ID 7, and then it will go ahead, find it automatically. Well, it doesn't have to find it because the update statement says league ID change, name change, where the ID is equivalent to the ID that it saw come in on the record. So it's doing all of that automatically once that record ID is there. So let's go through a number of permutations. If we did not specify this ID, what would actually happen, and I'm just going to use another football team. Let's use Seba United, and that is also in that Red Stripe Premier League. So let us try that one. And note the difference. This had no ID. We took the ID out, and it took that as a cue to do an insert. Take note of that. So the update command, or the update function, was saying that, okay, I don't see a primary key on this. This clearly doesn't exist in the database yet, so I'll go ahead and insert it. Now, I'm not touting this as an alternative to the insert. I like to keep them very separate. If I'm inserting something, I use the add function. If I'm updating, I use the update function, or I just track it accordingly. But tracking is not always an option like we're seeing in our applications. But one thing to note, if that ID is not present, it will go ahead and add it. So that's why we always make sure to include the ID information on a form so that when it is submitted, that ID is present in the record so that we can properly carry out that update. So that is a very important point to note. And one more experiment is putting an ID that does not exist. So if that ID value is completely incorrect, say I have 10 and we know that we only have, well, now 8 teams, right? Or teams with up to ID 8. So ID 10 is completely wrong. It will try to do the update, but then it's throwing an exception on the save changes, saying that the operation failed. Well, it expected to affect at least one row, but affected 0. There might have been some modification to the data therein. So you can see here, it's not really telling you exactly what's wrong. We know that this is wrong because the ID value does not exist, and it is saying that it thought it would do at least one change, but nothing happened. So it's not really sure what might have happened. You need to go and do some reading on the documentation. But like I said, I want us to see what can cause these errors, so that when we get slightly vague errors like this, we can surmise that, okay, there must be something wrong with some of the data that I provided somewhere here. So that's really it for the update. As you can see, it's a fairly straightforward operation. You have two options. Once again, you can go and find the record, make your changes, and then save the changes, and then tracking will allow EF Core to know that, okay, this record was modified, so I have to create the update statement for it. Because even if we got a list of them, if we made changes to only one, it will know that only one needs to be updated, right? And the alternative now, or another situation, might be where tracking is not necessarily an option, and the record that we get to update is not being tracked by EF Core at that point in time. So we can use that update method, which will go ahead and look for the record and generate the update statement automatically. If there is no ID present, then the update method will go ahead and add the new record. And we're back. So up until now, we have looked at all of the letters in CRUD except the D, which is delete. So we've looked at how to create. We spent some time looking at how we can retrieve and the different ways. We just looked at how we update, and now we want to know how we delete or remove data from our database. So I've already set up two methods, one to show a simple delete example, and then another one where we show a delete when there's related data. All right. So the simple delete. Let us take a look at the options that are available to us. And I'm going to spend some time with the leaks table because we have to do some cleanup. One, we have duplicates here and here. And then we also probably want to remove Bundesliga. So that's what we're going to be doing today. All right. So when I say context dot and choose a table, so in this case it's leagues dot, and then start typing delete, or rather remove, my bad, we'll see that we have two options. We have remove and we have remove range. So remove, just like add and update, deals with one record at a time, and then the range operations are for bulk. All right. So when I say remove and just take a look at what it requires to do a removal, we see that it needs the whole entity to be removed. All right, so typically when you're writing an SQL statement, you would say delete from table where maybe ID is equal to 1. All right, and then you will just know, go for the ID, go for whatever record matches the condition I was given and delete that. And without that condition, it will actually just wipe the table. So at least there's a safety net here where we have to either provide the entity or the list of entities to be removed, which means that we have to make a very deliberate effort to know that this is what we want to remove during runtime. So the risk of wiping the database is far reduced in this situation. All right. So of course, if we need to provide the entity that is to be removed, and if you just look at the documentation, it says that the remove puts the entity in a state called deleted. So it marks it to be deleted, but as we know, nothing happens until we call save changes. So if I need to provide an entity to this record, then clearly I need to go and find what I need to delete. So I'm going to put in a line right above that where I'm finding the league with the ID 4. 4 because that is one of my duplicates. All right, and this one doesn't have any related records. So this is a simple delete. just finding the one with the ID 4. When we get it, then we can say that is the one I want to remove. And then, as we know, we say save changes. Of course, using the async, I had to add async to the method declaration. All right, and there we go. So when I call that one, and I'm just going to comment out that second call for now. When I run this operation, we see where it carried out the select query to retrieve the record, and then it went ahead and said delete from leagues, the same query that we know and love. All right, of course, with that where clause to make sure we don't wipe the tables in the database. All right, so that is how a simple delete really works. Now, the reason I'm kind of differentiating between a simple delete and a delete with relationships is that when we have related records, a delete operation kind of becomes a bit more sensitive. Meaning, well, there's a setting called cascade delete, which means that if I remove the record with a primary key, then every other record that has a foreign key to this one will also be deleted. All right, so it would almost be like they delete you from a database, so all the cards you've ever owned and all the information relating to you will also be wiped out from various parts of the database. While that might be good in some situations, that might be very dangerous in others. All right, so in this situation, if I'm going to go and delete Bundesliga with the ID 9, so I'm just repeating all the same code from the simple delete. What makes it different is that I know that I have at least one team related to the Bundesliga. All right, so that means if I remove Bundesliga, then that team would also get removed. Just the same way if I removed Serie A, then 1, 2, 3 teams would be removed. Now, going back to our migration file, just so that we can understand the constraint rules, when the table for teams was created and the foreign key constraint was put in, by default, it gave referential action.cascade. There are other options that we could set here. So we could say restrict, meaning you cannot carry out a deletion on any record that has related or dependent records. Set null means that it will set all of the other records, all of the related records, their foreign key value will now become null, right? So it will delete the parent and just set all the foreign key values to null. And then you have no action, which is, well, that just, it says just ignore the constraint. And then another one that says default, which will just set a default value afterwards, right? So I'm going to leave it on the default cascade, but once again, this might not always be the best situation. And there are times when Entity Framework Core, in generating the migration, will actually indicate to you that if I put cascade there, it can run into certain kinds of errors, because, you know, this table might have a dependency on this and that, and you get a circular reference kind of situation, or different tables relying on the same data. So EF Core will kind of warn you in situations where your database design may not be optimal for this kind of constraint rule. All right. So with all that said, let us try and carry out our deletion on Bundesliga, which we know has a related team, and see what happens. So when we take a look at the SQL that's generated, it doesn't look any different from what we saw with the previous one. So you're probably wondering, okay, so where's the second delete for the related record? Let's verify that that happened. So if I refresh teams, Bundesliga is gone. Leagues, and then if I refresh teams, that means Bayern Munich is also gone. So the cascade did occur, but our logs only show one deletion. That is because a cascade rule is really in the database engine, and it's not necessarily an SQL statement that will get generated. All right, so that migration rule was really set in the database. When we effected the migration, the database itself knows that the rule is delete all related records. So that has nothing to do with EF Core at that point. So that is one of the potentially dangerous situations that you need to be aware of when you're designing a database, setting up your migrations, and carrying out your delete operations. Just know that by default, it will say cascade, but you can always override that to say restrict by default or anything like that through configurations. So that's really it for our delete operations. As you can see, it's fairly straightforward. We just need to go and retrieve the record. More than likely, we would have the ID for the record that we need to delete anyway. We go and retrieve it and then just tell it that's the one we want to remove, save our changes, and then that's it. Hey guys, welcome back. In this lesson, we're going to take a look at tracking versus no tracking so that we have a better appreciation of what is happening in the background. So I've already written some code. You can pause right here, replicate it, but I'm going to walk you through what each line is doing. So we start off with the method called tracking versus no tracking. And in this method, I have two statements. One, where we're getting a value from the database and I'm just calling it with tracking, and then another one where I'm getting it without tracking. So if you take a keen look at the two lines, the difference that you'll note is that I have dot as no tracking in the statement. So the first one is what we're used to, context.teams. I want the first record that has the ID 2. All right, that could almost have easily been a find, except the as no tracking does not work when we're using a find. All right, so if we were to try and find like we would have for delete and update and so on, we can't put as no tracking in this kind of statement. Hence my writing of the first or default. And then for consistency, I did it both times. All right, so with no tracking, I can say, give me the team. Don't track after you've given me. Please don't track it in memory, but I want the first or default with the ID 8. Now this kind of seems not intuitive the way it's written, because you'd probably say, so why don't I say give me the first team with as no tracking? The reality is that after the first or default statement, all of this pretty much becomes the object that we're looking for. So in other words, the only thing I can do after first or default, and well, we're using the async, so I'm just going to wrap that inside of parentheses. So after this statement executes, right, and I only have to do that because it's async. If it wasn't async, then I wouldn't have had to do that. But at the end of a first or default operation, we're going to start interacting with the actual fields that are in the object. So that is why that as no tracking just can't come after that statement. So we have to tell the DB context that look into the teams table, don't track the items, but I want the first one that meets this condition. And that is the statement. Now the real advantage to not tracking is that it actually releases memory a bit more and speeds up performance, because you can imagine that if you are retrieving 100 records all with tracking, then EF Core is going to have to be monitoring 100 records, and that's just on one request. What happens to all the hundreds of records that you might be juggling in the system, right? So then the EF Core engine has to work overtime to be tracking all of these all the time. So in a simple operation, like maybe you're just doing like a read-only list, like you're listing things in the database to your user, you can always just say no tracking, because you don't have to track things that are in a simple list, right? At the time, however, when you're about to make a change and you do a statement like this, then yeah, the tracking will be there. You go ahead and remove it, or even in the update, the tracking would be available after the find, so that we could, sorry, that's the wrong method, so that we could, here we go, make the change, and then it is being tracked in that moment to be saved. All right, but then for large read operations, you can always use the as no tracking to kind of reduce the attention that EF Core has to pay to each record being retrieved. Now, what I've done after retrieving the with and with no tracking, I've made changes to their respective names. All right, then I'm going to show you that we can actually look at the entries. So we have this thing called a change tracker as part of the context, which is basically just going to show us information about which entity is being tracked, what the state of it is right before the save changes, and then we're going to take another look at it after the save changes. I only did this as a precaution, but I'm sure that this will get updated afterwards anyway, but we will see. All right, so let us go ahead and execute. I've set a breakpoint at the save changes line, and I have the variables in the watch. So I have the entries before save and after save. So if I take a look in the entries before save, it will give me the results view, and it's showing me that only one of the records it is tracking as modified, right? So if I expand, you'll see that the entity state here, state, is modified. So we actually have some enums given to us by AF Core where we can say entity state dot, and you have modified, added, deleted. Anything that pretty much would be able to do in a CRUD context, we can tell what change is about to be saved or what state it is in right before it is about to be saved. So we see here that record with ID 2 is in a modified state. Record with ID 2 was the one that we retrieved with tracking. We made the change, and then right before we save, it sees that it is the only one it needs to save because we were not tracking the record with ID 8. So no matter what change we made to it, it just doesn't care. So that would be the scenario that gave us this situation where we would have the record, we know everything about the record, but then we have to tell the context that this team or this record needs to be updated, at which point it will start tracking it. So while it was here, it was not being tracked. This object is in the same state as this object, just not being tracked by AF Core. However, if we were to put in the manual update statement for with no tracking, then by the time it got here, it would also be listed as a modified record to be saved. All right, so I'm going to just step past that one and then do 2 more steps so we can see entries after save. And entries after save, now it only has it, so it's still tracking the fact that it had that entry before the save. Now it is in an unchanged state. So after we save the changes, they move from whatever state they were in, added, deleted, or modified, and they move to an unchanged state. So that means Entity Framework is still tracking it, right? Once it's listed here in the entries, that means it is being tracked. So there are times when you might run into some concurrency issues when maybe you're carrying out an operation and then you save the changes to the record and then you probably try to manipulate it again right afterwards, and then you might get an error saying that this is already being tracked by AF Core. So that is one of these situations. So sometimes you need to release it from being tracked, but we won't get into that level of complication, at least not right now. For now, we just want to focus on what tracking does differently from no tracking. So like I said, in a scenario where you only need data for read-only purposes, then as no tracking creates a very efficient scenario for you. Hey guys, welcome back. In this lesson, we want to quickly review our one-to-many relationship and how AF Core makes life easier in defining this kind of relationship and allowing us to interact with related records. So just as a recap, we have our league table defined as this data model, and we have our team table defined to the right. So we know that by following our naming convention, first of all, AF Core was able to infer that a foreign key relationship existed between these two. What's that naming convention? Well, firstly, I would have indicated that the field name is league ID. All right, so we have the table called league and the foreign key. Just by calling it league ID, it actually inferred that there's a foreign key relationship. So just as an example, if I did not include that virtual navigation property, this would still know that there's a foreign key just because of the naming convention that I have employed at this point. Now, because of the data type being used, I'm using int, and int by default cannot be null. So you would realize that that migration that was generated would have not nullable. Here it is, league ID was the column, and nullable is false, meaning it cannot be null in the database. Well, C# supports nullable data types. So if I said int question mark, then that would automatically be nullable. So I'm just going to run a migration just to show. So this is our migration. Add migration made league ID nullable. And then in this new migration file, it kind of looks different from the previous one. And we will be going through more migrations. I'm not focusing on what we're looking at just yet. I just want to highlight that the outer column is now seeing that nullable is equal to true, all because we put that question mark. So in C#, if you make the data type nullable, then that is how EF Core will know that it's a nullable or not null or nullable in SQL should be true, pretty much. Right, so it's saying that the old type was int, the new type is int, yes, but it is now nullable. So that is one of the ways that we can make a foreign key nullable. So why would you want to make a foreign key nullable? In a situation like this, maybe you can have a team without a league. So later on when we're adding more tables, one of the tables that we're going to add is a coach. A coach can be a coach. Well, technically, a coach can be a coach without a team, because my profession is I am a coach, but I don't have a team coaching right now. So I'm in the coaches table, but I just don't have a team. So at that point, that team ID would have to be null if I am not employed to a team at that moment in time. So that's just a quick example, which we will look at later on. But for now, I just want to focus on the fact that we can make that foreign key nullable. Now going back to our team data model, I've made a slight adjustment where I've removed the integer for the foreign key and I've replaced it with only the navigation property. That is also going to try and generate a nullable foreign key field. The only problem here, while the foreign key field will be generated in the database, without having the property in the class, there is no way to actually get that integer value or interact with that ID value, right? So that is why, for me, to make life easy, it's just best to interact with them both. Now, I've made that nullable, but I don't necessarily want to keep that chain. So what I'm going to do in the package manager console is remove migration. So we probably saw that one earlier when we're looking at all of the options or all of the commands that we can run. So to undo this action, it says it right here, remove migration. So remove migration will always try to remove the last or the most recent migration done. So there's our most recent migration. I can just say remove migration and it will kill that file. Please note, however, that if, and you see they're saying it reverted and it's doing everything that it knows it needed to. So the only thing though is that if you have already committed that migration to the database, then a remove migration becomes a tad bit more difficult, but that is something that we will also look at, so don't worry about that just yet. Now, one more thing I want to point out about these foreign key relationships is the fact that on the league side, I can add a property that is a collection of items that I know are related. So when we scaffolded the database, you probably took note of the fact that the league had a collection, an I collection. So this can be an I collection, it can be an I numerable, it could be a list. It really is up to you, but it will just infer that a collection of team, right? And I'm just going to call it teams, means that league can access automatically the list of teams related to it. So think about it. In general SQL, if you wanted the league and then you wanted all the teams in the league, you'd have to find the league maybe by ID and then go and query the teams table to say, get me all the teams with the league ID, right? Or you just get all the teams with the league ID, but then you have to inner join on the league table to get the details of the league they're in. So we're already kind of doing that because one, with team, I can get the details of the league that team is involved in. We'll look at that later on, right? But just by putting this collection type here, I can say, get me the league with ID 1 and include all the teams. So automatically I'm getting the league, I'm getting the name, and I'm getting all 20, 30 teams that are associated with the league all in one object. So that's another advantage. So I'm going to add this property and I'm going to leave it there. And you can do the same in your model. And the final thing that I want to point out really is I want to reiterate the importance of following the naming conventions. When you don't follow the naming conventions, you're actually fighting against the system that is designed to help you do things better. So in this particular situation, I am referring to, say, the foreign key creation, because you might have other ideas as to what you want to name this foreign key column, and I'm not going to say no. Your business rules may require you to use another column name, but then it becomes difficult, because if I wanted to name this league FK, and I know this is going to break some other code that I have in other places, but if I did this, what would happen is that when I run the migration, it is still going to generate a column called league ID, because EF Core is following its own convention. And then this is going to be a random column, a random column called league FK that has absolutely no affiliation with the foreign key. So once again, I just want to reiterate, follow these naming conventions and life will be much easier for you. Now, in the next lesson, we're going to look at the many-to-many relationship, and I'm going to delve some more into some of the awesome things that EF Core can do for you. Hey guys, welcome back. In this lesson, we want to start looking at many-to-many relationships. Now, the case study for a many-to-many relationship would be when you have many records relating to many records. Within our context of our football application or football database, we have to take into account the fact that there are going to be many matches between many teams. So many teams will play against many other teams over the duration of a season. I have on screen a nice, useful app called draw.io. It's a web app and it's completely free for use. And what we're going to be doing is visualizing our data structure. So I'm going to just use rectangles, nice and simple. And I'm going to call this one league, and we're going to call this one team. So we know that we have leagues related to teams. Nice and simple, just using an arrow to connect them. All right. So we have league and we have team. Now I need a new entity in the mix, and I'm going to call this one match. Now a match is going to comprise, and I'm just going to write out the fields in the entities. We already know what's in league and team, but this one is going to have an ID, of course. It's also going to have home team and away team. So you see, now I'm kind of veering away from the naming convention, right? So home team, away team, and we're going to probably have time. Like I said, we're going to end up with the same home team, the same team being home team multiple times, and the same team being away team multiple times, but they're being pit against each other. So this many-to-many relationship really needs what we call a linker table, which is a table that's going to sit in between the two related tables. In this particular situation, though, the many-to-many is really between many teams and many teams. So that means we have team being related to this table twice. All right. So forgive me if you're kind of new to database development, but that's just how it goes. Sometimes you have two foreign keys to the same table from another table, right? So one table has two foreign keys here. We have a foreign key for the home team, however, a foreign key for the away team. But then this is really saying that many teams are related to many teams, many to many. All right. All right, so now that I have visualized what this database structure needs to look like and this new table, we can go over and create the models for this. So I've gone ahead and created a brand new class that I'm going to call match. And just like its counterparts, it's going to have certain naming conventions. Now, before I move on, I just want to point out that every single table or every model basically has this ID. And then there are times when you're going to have multiple fields that probably repeat across all tables, like maybe when you're doing auditing, or you have date created, those kinds of fields that maybe everybody needs to have, because clearly all of our fields following the same convention, or all of our tables, will have a field called ID. Now, I don't want to keep on repeating this in every single, because, if we have 20 tables, then that's 20 copies of the same line of code. So what I tend to do is add what I call, let me call it common. And then I'm going to add a class inside of common that I call base domain object. So this is not a naming convention either. I just call it base domain object. People call it base data object. People call it base object, whatever it is. But this is really just going to be a public abstract class. I'm only making it abstract because when it's abstract, I can't instantiate it by itself. So it's really like a failsafe for me, but it doesn't necessarily have to be. But I'm going to take this ID property, place it inside of base domain object, and then every other entity can inherit from the base domain object. So that way I don't necessarily have to repeat the fields. If the field name changes, at least the common fields across them all, I only have to make the update one place, but everybody is inheriting from that one place. So everybody gets the field. All right, so I'm just going to do that for match. So now match by default has an ID field. Team, and I am not going to remove it from team, but I'm going to let team inherit. And then what you're going to notice now is that it's going to start complaining that it's seeing ID both here and in the inherited class. So that means I can safely remove ID from that class. So that's just a little trick that if you're not already practicing that you can now put in to make sure that you don't repeat code too much. All right, so let's move on. We have the match ID. Now I need a property that represents my home team. So I'm going to call it home team ID. Once again, this is breaking away from the naming convention. In the previous video, I would have mentioned how important naming conventions are, but there are situations where you really just can't follow the naming convention, because when I call home team and away team ID, if core doesn't know, or it's not going to infer that this means I'm referring to team and this means I'm referring to team. So we'll see how to navigate that in a moment. All right, so just adding the rest of the properties, I've added the navigation properties that will correspond with each foreign key. All right, so we have foreign key, and then I have the date, time. So I changed this to date instead of time because date can capture date and time. Right, so we'll know the date and the time of the match as opposed to my initial design, which only said time. So now that we have this new class or model defined, we know that we have to add to the DB context. We have to let it know. So I'm just going to duplicate that and add the new model to the DB set, and I'm calling it matches. All right, but I have to do something extra. So once again, I have broken away from the recommended naming convention. So I have to do some extra work to let it know that, hey, you are supposed to be a foreign key. So let's go ahead and adjust the team model to let it know that it should have two lists. A list called home matches and a list called away matches. Now remember that we did something similar for league. We have team referencing the league table. So we know that a team belongs to a league. However, a league has multiple teams. So in the same way, a match can have a home team and an away team. So one at a time for any one record or row. But then a team can have many away matches and home matches. So that is why we have to make sure that we put in these list navigation properties. Now, building on this, we have to let Entity Framework know that all of that wiring up means that there is a foreign key relationship between team and match. Right? Up until now, AF core is still oblivious to all of that. So what I'm going to start by doing is overriding our onModelCreate method. So we have onConfiguring. This means whenever you're setting up the context, this is what you should do. Well, this one is saying whenever you're going to create the model or do a migration, the next time you're doing a migration, make sure you have these rules in place. All right. So not to say every migration will repeat the code for these, but it just means whenever you're building out the database and dealing with the database, this is what I want you to do. So that's what this method is really there for. So I'm going to remove that default line, and then we're going to have to let the model builder know that our entity, So we're using Fluent API at this point to define certain rules, and you'll see why it's called the Fluent API. So our entity called team, and then I'm just breaking lines so we don't go too far out. And then we're going to say dot, and then you're going to see a bunch of options here. Now, I have gotten carried away and tried every combination, but not every combination works really. So you just have to kind of know what you're doing. So in this situation, I want to say that my team has many, right? And then we just define a lambda expression, m dot, and I'm going to say like home matches. A team will have many home matches. That is true. Then we go to the next line with 1. So what is going to infer at this point now is that you are going to have many home matches with 1 m dot, and then now we're seeing properties from the home matches or from the match entity. See that? So that's why it's fluent, because each line is based on the line before. So a team has many home matches, and then the home matches, or a home match, a match only has 1, and I'm going to say if I'm dealing with home matches, then it only has 1 home team, right? And then I'm going to have to tell it that, and it has a foreign key, lambda expression again, m dot, and then I can specify which foreign key facilitates this has many with 1 relationship that I am telling it about. So I'm going to say the foreign key is home team ID. And I'm hoping that you're starting to see that, naming your columns properly, if it can't help EF Core to figure out what you want, it helps you to figure out what you need to do later on. I'm also going to add a constraint to say that it is required. And to finalize, I'm going to define the onDelete behavior. We already discussed the onDelete behavior, where we know that it's a configuration for the database. So I'm going to say cascade. That means if I delete a team, I want all the matches to go with it. That may or may not be what you want to do, because maybe for the archives, you will want to keep the team and all the match data around. That's up to you and your business rules, of course. So I'm going to just repeat all of this for the away team. And you'll see that both are identical. The only difference really is that I put away matches and away based columns where they were the home columns. And that's pretty much it for defining the rules around this many-to-many relationship. So there are quite a few times you might have to get your hands dirty like this. In this situation, it's a very unique one because 1, we're not following naming convention with our foreign keys, and 2, it's the same table relating to another table twice. In another situation, and let's say, and I'm just going to give you an open scenario here. We had a table to store the products, we had a table to store customers, and then we have another table to store the products that customers have ordered. So many customers can order many products. So that middle table needs to have the customer ID and the product ID. All right, think about that scenario. Now, in that scenario, it's a nice, clean relationship. It's an easier relationship to define than what we had to do here. And then in that situation, really and truly, you would just need to put the list navigation property on either table. And then EF Core would just infer that there is a customer product table to be generated. Sorry, I stuttered just now. But there should be a customer product order table, for instance, to be generated, because you just told it that customer would have a list of products and products would have a list of customers. So it will just automatically know I need to create a middle table for this many-to-many. And literally it would be many being the list to many. So there are different scenarios, and each scenario may come with its own quirks. This is the quirk of our scenario, and I think it's good to do the harder scenario because at least you get to see what might have to be in place should you run into difficulty, and your scenario is not as easy as it could be. Now, with all that said and done, let's go ahead and run our migration and see what we get. So this is our migration file. It's creating the table called matches. We have our columns being defined, and then we have the constraints being put on the table. which indicate our foreign key relationships, right? So foreign key number one is is on the column away team, and it's between teams and that ID, and on delete is cascade, and it's just the same for the home team. All right, so with all of that done, let us update our database. All right, so if you updated your database just like I did just now, then you would have gotten this error. If you didn't, then shoot me shoot me a message and let me know that you didn't. But this message just came up, and like I said before, I'm not going to shun errors because these are the kinds of things that make people afraid of this kind of technology. So it is saying to us that it failed to execute the db command, create the table. And if I scroll all the way down, it's going to say I'm introducing a constraint, or in introducing this constraint, it causes cycles or multiple cascade paths. So in other words, what it is saying is that having this referential the delete action cascade on these two foreign keys can be problematic to the database structure. So maybe in designing the database manually, you probably could get around it, because I have never been warned by SQL Server directly about something like this, but EF Core is just letting you know that that can be problematic, and it has an error trying to do that for you. So what we can do, and what we will do, is just remove this migration for now, and following EF Core's suggestion that this delete behavior is problematic, I'm just going to do a restrict. So in other words, you cannot remove a team unless you have removed all of the matches before. All right, and I actually see where that is reasonable, because when I said it earlier that you delete a team and it automatically wipes out the matches, that could be problematic. All right, and especially where a team could be on the home team ID or the away team ID, and then that is going to end up deleting data for teams that are still in the system. So that was a poor design choice on my part. No problem. EF Core has warned us, but once again, I just want to help you to understand what that error really means. So if you see that kind of error coming up, it is maybe because we need to change that delete behavior. Remember that it's going to be cascade by default. So even if we didn't define cascade here, you probably would have still gotten that error. So it's important to understand how to mitigate against that error should you get it. So let us try and add that migration again. And this time you see it saying that it is restricted. That's fine. Let us update database. And this time I get done. And looking at it in our SQL Object Server Explorer, we see that we have our ID and we have our two foreign key columns that are not nullable. So that is one way of setting up a many-to-many relationship. Like I said, it may differ based on your situation. Given the structure of our database, this is what we had to do to accomplish all of this. These are general guidelines, of course. So when you are creating your many-to-many relationship, you can basically follow these guidelines and you would be able to create it no matter how complicated or simple it might be. Hey guys, welcome back. In this lesson, we'll be talking about one-to-one table mappings or one-to-one relationships. So I've already gone ahead and created a new entity model and we're calling it coach, and a coach will be used to depict the one-to-one with a team, because in our situation, in our database, a coach can only belong to one team at a time, and of course a team has a coach, right? But then if the coach gets fired tomorrow, then let's just say that team might not have a coach and this coach might not have a team. So, those kind of unique business rules or constraints can drive the rules that we put in or our database design. So let us go ahead. We already have coach inheriting from base domain object. Like we said, base domain object is providing that ID property by default. So we can go ahead and focus on all the other properties that are more unique to the coach. So the first property for a coach, as you probably would have guessed, would be the name. Now, I'm not getting too complicated with the database, but we know we have a coach. A coach is going to have a name. At this point, I'm not going to include any more details about this coach, but I will include the fact that this coach has a property called team ID. So this team ID, as the name suggests, will be the foreign key to the team table. Now, our team or teams table needs to have some representation of a coach. And what I'm going to do here, keeping it very simple, is just reference the coach. So just like that, the coach is going to be a part of a team, or related to a team, and the coach table also knows that it is related to a team. I'm going to make this nullable. Now, when I was talking about the rules and so on, I went through the scenario that the coach can exist in the table without having a team. So if I don't make this nullable, then it's going to be required. It's not always required, because if he gets fired, he's still a coach just without a team. So I'm making it nullable so that the migration will know that in the database, this can be null. At the same time, in our team table, just by doing this, it knows that, okay, this can be nullable, so it won't have to make any additional effort for it. Now, navigational properties once again help you to get the details of the related entities. So when I get a team, I can get the details of the league it's in, I can get the details of the coach, and I can get all the matches if I need to. From the coach's perspective, if I'm looking at the coach, all I have to go on is a team ID. So if I wanted to, I could include a navigational property. I'm just going to copy and paste to move along more quickly. I could just include that team navigational property right here, so that if I get a coach, I can also include the details of the team and all the matches and everything. All right. So let us take a look at the migration that we can generate from this. All right, so my migration added coach team 1-1. So our migration is generated, and we can just take a quick look and see that we are getting the new table called coach. And if you've noticed, we've actually skipped one of the more vital steps. I don't know if you noticed, but we skipped what I have touted as a vital step towards creating a table, and that is to include it in our DB context. We did not include our new table called coach or coaches in our DB context. So let's look at that now. The fact that I have told a table that is in the DB context that it references this class or some class, the migration or EF core is just going to go ahead and create a table that represents that table name. So that name is being generated based on the property name, which is coach. So this might not be the best approach if we're going to be standard with our naming convention, because up until now, we've always pluralized every table name. So I'm just pointing out, though, that by adding that navigation property, EF core is automatically going to insert or create that whole migration around creating a table for that navigation property. So I'm just going to remove the migration, however, because we want to kind of keep standard. And I'm going to add it to the DB context. So we have a table called coaches. Redo the migration, and then we can feel a bit better about what is being generated. So I'm just pointing out certain things that EF core will kind of do behind the scenes, even if you miss a step. So you want to be kind of deliberate, but EF core is going to make certain assumptions for you based on how it knows it needs to operate. Let us go ahead and update and that is done. So I just want to point out also that the create index kind of looks a bit different from what we might have seen up until this point. And it has a filter, team ID is not null. So just looking at it, you're probably wondering, okay, what does that mean? Especially since we told the table that team ID is nullable. Well, if we look at the statement that was generated for the create index, we are creating the unique index on that column when it is not null. So once there's a value there, that means you can't repeat that value on any other coach. That's pretty much what it is saying, but it is allowed to be null regardless. So that's really it for setting up a one-to-one relationship. Once again, the scenario for that would be when you know you only want an entity to be associated one time with another entity. And there are different scenarios when you have one-to-one relationships. It could also be that one is entirely dependent on another, meaning it could be a scenario where we only want to have a coach in the system when he's associated with a team. Outside of being associated with a team, he shouldn't be in the database. So you do have that scenario also, but once again, your business rules and your requirements will drive the decisions you make during your design. Hey guys, welcome back. This is a quick video. I just want to show you how you can update your database diagram. So we've been making quite a few changes. We've added new tables, added new relationships, and I just want to show you how you can update the visual representation of your database. And it's pretty simple. The same way you did it the first time, you just repeat that step and it will create a new diagram and change it for you. So you just right click your project, you go ahead and go to EF Core Power Tools, add DB context diagram. It will just go ahead and generate a brand new one for you, and you will see it here. So we have our new entities in the form of coach, and you'll notice that the arrows are showing you the cardinality of these relationships. So you can tell off the bat that this is being seen as a one-to-one by EF Core, this is a one-to-many, and this is also a one-to-many. You will also notice that the navigation properties have been updated, where a match has an away team and a home team. However, team has lists of away matches. And of course, if you hover over any one of these blocks or properties, they will show you what category. See, it says navigation collection, dependent on match, and its type is list of match. So this is a great reference diagram to give somebody who might not necessarily understand or want to comb through each class to see exactly what's happening. This nice overview diagram is a great way to get up to speed with what references what and how these relationships are formed. Hey guys, welcome back. In this lesson, we will be going through some examples of when we will need to add records that have relationships. So earlier when we were looking at our insert scenarios, we actually looked at one, and I've repeated it below, which is to add new teams with league. In that scenario, we had a league that didn't yet exist, and then we had a team which also didn't yet exist, hence the create, right? And then we added this team while passing in the league object. And then we noticed that when we called add and save changes, what happened is that it created the league that didn't yet exist, and then it automatically inserted that foreign key relationship with the team. So you can revisit that insert video and review what happened when we did this operation. Now I have a few other scenarios that we would want to go through. One is when we add a new team with the league ID. And I think this one is probably a more indicative scenario of what would happen in a software situation. So now when we're adding a new team, add new team with league ID, this is probably what's going to happen maybe from a web interface, right? Somebody's typing in a team name, and then they would probably indicate which league this team belongs to through a drop-down list. So you would have this scenario if you require the user to enter both at the same time, enter the team name and the league name. Then yes, you could go ahead and manually create the objects and then do one save changes and both get committed. Another more practical scenario though would be that you have the list of leagues, and when they select from that list, they would have sent over the ID of the league that was selected, as well as the name of the team that they're entering. So we already have some leagues in our database. Let me just go and fetch them quickly. So we can easily simulate what IDs would be the potential IDs for a user to select from. So let us say they wanted to add a new Serie A football team. Then our code would look something more like this. We wouldn't have to create that league object, but we would create the team, and then we would pass in the league ID of 8. So in this scenario, the league already exists. We know its ID. We're adding it to the team. We're adding the name to this brand new team, and this team is going to be Fiorentina. And then we can go ahead and add it, and then that relationship will be strong. Now, one of the benefits of having relationships and, well, relational databases are designed to kind of enforce this consistency in its data. We lessen the risk drastically, if it even still exists, of having a league that doesn't exist being associated with a team. So I already looked at the fact that we do a cascade delete. If we delete the league, then all the teams would get deleted, right? But then I cannot add a team that is related to league with ID 50 when we saw that 8 was the max. EF Core, well, the database itself will reject that. EF Core will attempt it, the database will give an error, and then it bounces back. So that's one of the benefits of having this kind of strong referential integrity enforced in your tables. There are people who don't like it, but you're using a relational database, use it to your advantage. All right, so that's scenario 1. Scenario 1 was when we could just put the whole object in and add both, and the relationship would have been created, or that relating data would have been created in the background. Our other scenario, which is more practical, would be when we get the ID of the related record and then we pass it up into the record that we intend to create. Now, our next scenario would be when we want to add a new league with teams. Once again, that might be a scenario where you're creating the league and, you give the user the opportunity to add a new league, add all the teams, and then they submit one time. So that means in this situation, you need to create the object for the league and you need to tell it the teams that it has. And much like how the add context would have added both objects new and then set up the relational values, it would be the same scenario here. So I've already done that function where I'm adding a new league with teams, and then I have var teams is equal to a new list of teams. So let's just say that this is what the user has submitted, as well as the name for this new league. So you can tell that I copied and pasted, right? So this new league is CIFA, short for Cayman Islands Football Association. Let's work with that. And these are some of the teams that would be in CIFA. So when we add this new league, which is an object of type league, and it has its name and its list of teams, Entity Framework will do the rest when we save changes. In this next scenario, we're looking at creating records for our many-to-many table. So remember that matches represents our many-to-many table where many teams are going to play against many teams, right? So this function simply defines a list of type match, and it has a few matches with the away team ID, home team ID, and the date of the match. All right. Now, I'm kind of doing a 2-for-1 here because we're looking at how to create the record for the many-to-many. And remember that our match or our many-to-many table generally would have the ID as well as the navigation property. So the same way that we could put in the object for the navigation property and have it added to the database, it's the same way here. But in a more practical scenario, these teams would already exist by the time we're adding a match. So what we need to do is make sure that we're referencing the IDs properly. With a user interface, of course, you restrict the values that the user can enter to values that are more than likely going to be valid values to reduce any mishaps by the database trying to enter the records. All right. So that is part 1 of the 2-for-1 in this scenario. The next part is the fact that I'm using this add range. So up until now, we've always just been doing add, right? Add represents 1. We're only passing in one object when we say add or add async. However, when we say add range or add range async, then we can pass in a collection of values and all of them will just be added once we save changes. So traditionally in older versions, you'd probably put this in a for each loop, and then for each one in the list, you add, then save changes. Now in our final scenario, there's nothing really special happening here. We already know how to add one record, and the fact that we have a one-to-one relationship in this scenario does not change the fact that it's the same bit of code to just add one record. So we have a coach, and this coach's name is Jose Mourinho, and he is going to be coaching team ID 3. Now remember that this is actually a nullable field. So let us say we had 2 coaches and one did not have a team. So I'm going to say Antonio Conte, and this coach does not have a team. All right. There's the same way that I can add Jose Mourinho with the team ID, I can add Conte without the team. The only thing is that he will kind of be orphaned. He'll exist in the table, but he has no relationship to a team. So as soon as he gets hired, then we simply update his record and he'll have that related record for the team. So as it stands, if I execute this, we see both coaches being entered with no errors anywhere. Antonio without his team ID, as well as Jose Mourinho with his own. So I had commented the other functions out. Let me uncomment, and then we're going to just execute all of them and see exactly what's happening in the code. So let's try that again. All right, so everything has executed without any errors. So we see we're adding Bundesliga at the top, we're adding Bayern Munich, we're adding Fiorentina, we're adding FIFA. So you can see that even when we clumped the objects, the EF core once again knew intelligently which one is the dependency, insert that, get its scope identity, and then use that to insert whatever else is appended to it. So here we see we're adding Rivoli United alongside CIFA. So CIFA has an ID of 11, and that's why Rivoli and Waterhouse both have 11. That scenario was we're adding one league with the list of teams. For the one with the matches where we added range, you see that it just went through and added each one individually. Now you're probably wondering, why didn't it just create one insert statement and do it line by line? Well, that goes back to the bulk operations. The EF core team decided that unless you're dealing with a certain number of records, that batching those commands is probably not worth it. So that is why for smaller commands or a smaller number of records, you'll see individual SQL statements being executed for them. So that's really it for how we can go about inserting related data. Once again, this might seem unintuitive because we're hard coding the data and we're using a console application. But in a web application scenario, just remember that you would have given your user a form which would limit or allow you to restrict them to insert only data values that you know you need to carry out the save operations. So when they fill out those forms and submit, you would extract that data. If it is that they were creating a new league with a list of teams, well, we see how we can accomplish that quite easily. These are just guidelines as to what can happen in the backend once you have the data that the form or the user rather would have submitted via form. You know how to build it and then send it over to EF Core and let EF Core do the rest. Hey guys, welcome back. In this lesson, we're going to be looking at how we can retrieve data from multiple tables using one command. Now, a scenario for that would be if you have a report or some display of data that you need to accomplish, but then the data that you need to display is spread across multiple tables. Now, one, this is where referential integrity comes in, because you know that you can always go and get the related data from another table. But then if you're familiar with traditional SQL, you would also know that you have to do either some form of join. It could be right, it could be left, it could be inner, but you have to do some form of join in that SQL query to retrieve the related data. It is not very different from what we would have seen with our simple select queries, except we're going to be looking at a few more things. So I have the simple select query here for reference, and we know that we execute with that to list, and that is how we get our data. Now let's take a look at some scenarios that I have put together to see how we can play around with the whole concept of including related data or eager loading. So firstly, we're going to look at how we can get many related records. And the scenario here is that what if we wanted to get all the leagues and all their teams? And just think about displaying this data to a user, right? You have the list of leagues, and maybe when you click on the league, you see the teams. All right, so you want to get back all the leagues and all the teams related to them, maybe not all in one call. For whatever reason, your scenario may determine why you would need to write this kind of query. There's no problem. Entity Framework Core allows us to do it all. So what we would do is, just like a simple select, we're going to say var leagues is equal to, and then we await our context, which is going to call our leagues, and then we're going to simply say to list. So that would be what we do to get the leagues. Now we want the teams that are associated with the leagues, right? So before our to list, we have another function that we can use called include. Include allows us to put in a lambda expression. So you see how lambda expressions work. Now you see that they're not unique to filters and so on. There are certain functions that use lambda expressions, and you can always tell a lambda expression is going to be used based on the data type, which is expression func, and then you'd see the league object or the object of whichever table you're on. All right, so we're basically saying, what do you want me to include? That's what this is asking right now. And I want to include q dot, and then I would say teams. So right off the bat, we're going to see this query being run to give us back basically select star from the teams with the inner joins on the team IDs matching the league ID, or the league ID rather, in the teams table matching the league ID from the leagues table. So let's just quickly take a look at that generated SQL statement. And there we see select, and then it lists out all the columns from both tables. So leagues is L and teams is T. So it selects all of the columns between L and T, and then it's going to left join teams on the league ID matching the team league ID. So because of that referential integrity that we have enforced, EF Core clearly knows how to formulate that query to know which columns should map to each other in that left join. Notice it's using a left join. That means that if there's a league in the database that has no teams, because we're querying the leagues table, it's going to bring back that league. However, the teams object will be null. So let me just put a breakpoint there at the end of that execution, just so you can see what that will look like. So this is the data coming back in that leagues object. And if I expand, then you'll see ID2 Red Stripe Premier League and the teams that are in that Red Stripe Premier League and all of the details. So this team has no coach. It has the ID 7. You see that it is related to league with the ID 2, and you can get the name. So right there, you can say league object dot teams dot, and it just access anything you want, all from the leagues object. So that's the power of our eager loading. So we have some other examples that we want to go through just to show you how you can mix and match and the different things you can do based on your situation. So we looked at getting many records with their many related records, right? So we're getting all leagues and the list of teams per league. That might not be the case. Maybe you only want to get one record and a related record, or a list of related records, but only one record. So in this situation, we want to get one team and the coach details. So for this one, I'm going to say var team is equal to, and we await our context as it calls our methods here. So if you look at it, context.teams.include. But then, as we established, even when we say context.teams, it does nothing until we put on that executing command. Now, I did say I only wanted one. And if you remember, the way to get one would be either single or default or first or default. In this case, I'm going to put first or default. So I want team with the ID, let's say 2, and the coach for the team with the ID 2. Or let's say 3. I think I'd put in the coach with ID 3. We can just go back and check. So team with ID 3. There we go. So I'm going to say dot include, then put on my executing command, which is in this case first or default, because that is the executing. I only want one. So first or default takes the lambda expression, where I'm going to specify that I want the team with the ID being equal to 3. All right, so that's how you chain these commands along. I'm just breaking the line so you can see where each function really starts. All right, so context.teams, get me all the teams. Please include the coach, but then I only want the first or default one, where the ID is equivalent to 3. So let's take a look at what we get when we execute that one. All right, so our SQL that gets generated is pretty straightforward. Select top, and we see the same kind of join that's going on. So because of the first or default, we're selecting the top one, and then we have that where clause to filter down to where the team ID must be 3. So I hope you're seeing the common theme going through. So I'm back in the code or in the watch window, and you see here that coach, the navigation property, has all the details of the coach. So that is the power of our include. And one thing I want to point out, which is something that can be frustrating if you don't realize what's happening, where you place the first or default has a lot to do with if the statement will work or not. Well, it will just give you an error. So if I put context.teams then first or default, I cannot do an include after a first or default, because a first or default really turns this into an object of type team, and then all I can access are the properties. Because I'm using the async, that is not being shown clearly. So let me take off the async and show you that when I say dot, I'm really just getting the properties, home matches ID, right? So if that's what's coming after first or default, then clearly include is not in this list, and so we end up with that syntax error at that point. Now, in my early days, I did not appreciate this much, and I used to think that entity framework was buggy, but really and truly the order matters, right? So you want to do all of the database related things, and then you leave your executing statement for last. All right, so once again, we're going to go get the teams, include the coach, and then first or default, and those red lines are because I need the async. And there we go. All right, guys, so for our next scenario, we're going to be looking at grandchildren inclusion. So when we talk about grandchildren, it's just a matter of the hierarchy. The first table that we're querying, let's say that's the parent. Then the first table or the next table that we include is the child, but then we can have multiple includes. So all the children are ones with direct foreign key relationships to the main table being queried. So those are children. So you can have multiple includes for just the children. However, there might come a time where you need additional data from the child, and then you'll have to look into another table that is related to that child. So in this situation, we're going to have to get team, then matches, and then when we get the matches, we know we either get home or away matches. But then we need the details of the opposing team. So if I'm the home team, I need the details of the away team. If I'm the away team, I need the details of the home team. So I'm going to have to go into the grandchildren, because matches will have the navigation properties for the home team as well as the away team. So once again, we leave our executing method for last, and we do all of our includes before we call that final part of it. So I'm going to start off with an include for our away matches. All right, so I am team number 1. We want to see all the away matches, and then we can see that. But then when we include the away matches, all we're seeing are the details for the very team that we got, but I don't know anything other than the ID of the home team. So I can chain and say then include. Then include gives me access to the properties of the child. So include gave me access to the navigation property of the table, or the object that represents the table. It gave me access to that navigation property. Now I want to include a navigation property in that child. So I can say then include and use the lambda expression once again and say q dot, and I can look for the home team. There we go. So I have the away matches, and from the away matches, which is of type match, I want to include details on the home team. On the flip side, and I did say earlier that all the children can be included side by side. So I do have this include, and then I have this then include, right? So what I'm going to do, I don't want to confuse the issue. Let me show you multiple includes for multiple navigation properties before I show you the grandchildren. So we just saw an example of the grandchild, right? But I'm just taking a step back and showing you that you can say include as many times as you need to include directly related properties. So I can say, get me the teams, and for every team you get me all their away matches and all their home matches. Once again though, when it's an away match, I need the details of the home team. When it's a home match, I need the details of the away team. So then I can say, after you include the home matches, I want you to include the details of the home team. And just the same way, when it's a home match, I want you to then include the details of the away team. And then we can call our executing. So whether we call it first or default or to list, but the point is that is our query to get our grandchildren. And then the thing is, you can actually chain this across because, you know, based on your database setup, you may have multiple tables with children upon children or foreign keys upon foreign keys. So as long as you have a foreign key involved, you can say then include, you can include. But then remember that the include allows you to directly reference the foreign keys related to the main table. And then for every include, you can say then include, and then you can continue to then include, then include. And notice that the then include does not stop me from doing an include afterwards, because even if I did all of that in one line, it's a little less readable, which is why I broke it into 2 lines. But you see, I'm saying get me the teams, include the away matches, then include this, then I'm going back to include. But obviously the then include can only follow the include, because I can't then include after a table that doesn't have the navigation property I'm looking for and expect to find it, right? So I include the away matches, then I say when you get the away matches, then include the home team for the away matches objects. Then I go ahead and say also include pretty much the home matches, and when you include that, I want you to then include the away team details. After you formulated all of that, I only want the one with the ID of 1. So let us take that for a spin and see what we get. So firstly, let us pay attention to the SQL being generated. We have all the tables that we're getting. So you see select T0, T4, T2, all of those are there. And then we have from, but then it's using a subquery. So we query the teams where the ID is equal to 1. I will call that T0. Then we left join that on, and then we're selecting from matches, and then we're inner joining it back onto teams. Right. So the complexity of the SQL will vary based on how the relationships are really set up. In this situation, it's almost like a circular reference, because I'm looking at one team and then I'm saying, when I'm looking at matches, please go back and bring back the team. So it's kind of going back to the team table, which it just queried. But that's just a situation that we have to work with when we're doing this kind of thing. All right. But then once again, you don't have to hurt your head over trying to work this out, because EF Core generated it for you. Now, what it returns is the team with matches and opponents, and that should have been team, apologies. But then we have the away matches, which is only 1. So this team with ID 1, which is Juventus, only has 1 away match and 1 home match. Okay, fine. The away match, we know the away team. That's implied because we included the away matches, so we know we are the away team. Juventus is the away team. We don't need that one. However, we did need the details of the home team, and we got that. So here we see that it is Inter Milan, and I think Juventus stands a good chance because they don't even have a coach. All right, so then Juventus may just win that away match. If we look at the home matches, it's the same situation. We are the home team. This is the home matches, so obviously Juventus is the home team. But if we look at the away team, we see that the away team is AS Roma and the coach is null. But then if we had included the coach, so what if we wanted to include the coach alongside this? So that's another, let's just do that one. So what if for every team that we're including, we want to see who the coach is. We want the coach details. So I can say, once again, dot, then include. So when you include the home team, I want you to then include Q, and then you see it's just going down the chain and giving me the navigation properties according to what is next in line. So I can just say then include the coach, and then this will bring back the details of that team's coach. So let me just do that again. And we're in the middle of looking at the home matches. So we see that we are the home team. Away team is AS Roma, and the coach for AS Roma is Jose Mourinho. So that's a good coach. We're going to have to bring out our A game to win that match at home. So that is how you can go ahead and chain your includes to make sure that you're getting all the data from all the related tables. And this is another strength of having relational integrity properly implemented and working with EF Core. EF Core is trying to make your life as easy as possible. So this just cut down a whole bunch of joins and inner joins for you, because if we look at that SQL, it just got a bit bigger because now we have to inner join or left join the coach on the table. And notice that it's saying inner for some and left for some. So it's automatically knowing that if it's nullable, then it's a left join, because that means there might not be anything on that side of the table. However, when it is not nullable, it will just do an inner because it knows that they have to be an absolute match for me to bring back something. Now, I had these two other examples earmarked, but I think we kind of exhausted them all with these three, because these three are quite comprehensive in terms of what they are depicting that you can do when it comes to includes. This one says with filters, we already filtered here, but the main idea behind showing you one with filters would be that if I was to say get all teams with home matches. So it's a simple enough query. We await context.teams, and I'm going to add the where clause for my filter, and then here I'm just saying home matches, which we know is a list, dot count is greater than 0. So that means get me all the teams that have at least one home match, and I want to include their coach, and of course it's a list. So that is the SQL statement that gets generated for us. You can sit down and take a look at it, of course, if you need to, but then we see that we have 3 teams coming back that have no home matches scheduled. So you might be tempted, when you look at the data, you might be tempted to say, well, why didn't we just check if home matches is null? And I mean, I would understand, because we're saying home matches dot count is greater than 0. What if I had said home matches is equivalent to null, since that is the data that we see? But how exactly would EF Core be able to translate this list object into null? Because remember that SQL doesn't know anything about lists and lists being null. So if we look at the SQL statement being generated for this, well, firstly, there is no data coming back, right? So that query, whatever query this generated, is not bringing back data that we expected. Now, if we look at the SQL query that was generated, we see it's a regular select query with the left join, but then this filter is just throwing it all the way off. So that's EF Core's way of saying, I can't make out what you want me to compare in this situation, right? So while we may not have gotten a syntax error or any form of warning, we just want to be careful when we're adding our filters, and we might get a little overzealous with how we're doing it, and that's fine. It's good to experiment, but just be careful. So that's it really for us exploring how to query related records. And as usual, I'm going to just leave that method there so you can reference it later on. I'll just clean up what we didn't go through, and you have those examples to review afterwards. Hey guys, welcome back. In this lesson, we'll be taking a look at projections and anonymous data types. Now, you're probably looking at this topic and wondering, okay, what exactly are we talking about here? A case study for this would be that you have all of your models, sure, but then you want specific data from a query, and even more so, that is the only bit of data you want to return. All right, so you want to have like a custom object with only bits of data from all of the data set being returned, and that is all you really want to taxi across in your system. So let us go through some examples of what when you would probably need to do something like this. All right, so I'm going to show you 3 scenarios when you need to know how to handle a select. The first one is when we want to select one property. Like we said, maybe we're querying the entire teams table. So let's say var teams, and whether it's one team or many teams, the principle would remain fairly the same, where we have to say context dot and get the teams, and then let's work with a list in this situation, right? Which of course we have to await. Now, I don't want everything out of the team because we know that what we're going to be getting is a list of objects with name, league ID, and then if we include then the other things, right? I don't want all of that. What if all I wanted were the names? I just wanted the list of names. I didn't want any complex objects or anything else, right? So in that scenario, what I would have to do is add a select. So I would say context.teams.select. And then when I do that, I can use my lambda expression to specify which property I would want to select. So if I select name and then execute the toList, then this is just a list of string. All right, because name is a string and I said I want the list of all the names of the team. So I get the list of type string. And that goes for pretty much anyone that you do. So if I wanted all the league IDs from the team table, then I would be getting a list of integers. This keeps on disappearing. There we go. A list of integers because league ID is an integer. And that's just how it would go for anything. List of coaches. All right. So that is how you go about selecting one property. Now, the scenario might be that you don't only want one property, you want multiple properties, and even more so, you probably want multiple properties from multiple tables. All right, so let us look at anonymous projection. What if I wanted to select all the teams and I wanted all the coaches included, and all I really wanted to return, however, was the list of, well, a list containing the team name and the coach name. That's all I really want. So we know from our previous experience with the includes that would end up doing something like this. Let me say dot include, and then I'm going to say make sure you give me the coach details or the coach object along with the team. But then I want to select multiple things. I can't comma separate this. This doesn't work. I can't say q dot. So we know in SQL when you want specific columns, all you have to do is say column name, column 1, comma, column 2, etc., all before the from. That's not really an option here. So that's why we talk about projection into another data type. So on the fly, what you are allowed to do is something like new, and then you can open up a brand new object directly in that select statement. All right, and then if you hover over it here, it says it's an anonymous type. We know that C# is strongly typed, right? So everything in C# is strongly typed. It's either a string, it's an int, or something. But in this situation, I'm just saying new. There's nothing after the new to say a new what, right? So it's just a new blank. But then notice there are no errors, and it is assigning it an anonymous type. So it doesn't know what data type it is. It just knows that it's some type that I want to define, and it has a property of type string called name. So you see it's already inheriting the name given by the field. So in this situation, Q represents the team. So if I wanted to be specific, I would have to say team name is equal to q.name, and then if I hover over it again, you see that it evolved. It says this anonymous type has a property called team name. All right, so what if I wanted the coach name also? So I can now comma separate because now this is an object. So let me just break this out into a new line so that you can see where everything is happening, where everything starts and ends. All right, so here's our new object being defined. So we have lambda, then we're projecting into this new anonymous type, and we are defining on the go which field names it has and what values it gets. So team name gets q.name, and then coach name And don't be intimidated by the fact that what you're typing doesn't come up in IntelliSense, because once again, we're doing this on the fly and it's just going to work with us. So Q dot, and then I can say dot coach dot name. So right there, it's going to have two properties, team name and coach name. If I hover over teams, then you see it's just a list of this anonymous data type. All right. And then we're just projecting it into a list. So then after this, I can now say for each, and I'll just do a for each here to print them out. For each item in the list of teams, I can console.writeLine and print team and put item.team name, and I'll just do a pipe as a delimiter, coach and item.coach name. So even after this projection and this very random and spontaneous creation of this anonymous object, we can easily access the properties that were defined. So if I modify its definition, then item loses sight of the fact that team name was a property. All right, so that, I guess, that's as flexible as C# gets, and it can be very convenient to do at times. All right, now there is a case study for this, and it can be very useful, like I just said, but personally, I prefer to have a strongly typed projection, meaning I always know the object types that I am interacting with anytime I run a query. So like I said, there might be a case where you need a custom object, and this is good for an on-the-fly scenario. However, in a bigger project, you want to have a bit more control than just having these new anonymous objects all over the place. So what you would want to do is have a strongly typed class, and what I'm going to do is I'm going to create a new folder inside of domain. It shouldn't go inside of domain, but let us just work with it. I'll just call it models. By right, you would probably want to create a new project, but this is a very small demo project, so I'm not going to go too wild west with a number of projects. But in a bigger project, you'd want to have this in a dedicated space, not mixing with your domain objects. But I'm calling them models because really they're models of the data. So this is a model of the database data, but then what I'm going to be creating is a model of probably like custom data that I know I expect. So let us say a model would be a class called team detail. All right, so team detail is going to have a few properties. Let us say team detail has the name of the team. It's going to have the coach's name, and it's going to have the league name. Those are three different data points than we would ever be able to get just by running a regular query. We'd have to include everything about the coach, and we'd have to include everything about the league name, and then it can get kind of annoying on the receiving end when you have to say team dot coach dot name team dot league. You understand? So you want to just have one object where everything is just there for you. So that's why I call it a model. All right, so we can project into this strongly typed query. So I'm just going to copy this initial query. Let me just say the entire thing. And I'm going to add an include for the team. So remember, it's your query. Whatever data you need, you go get it. So I need team detail, the league. It said team. So we're looking at the teams table, and we're getting the coach details included, and we're getting the league details included. And then I'm going to select into a new instance of team detail. Right, so we were anonymous up top, but now we know what we're all about below. Team detail has name, it also has coach name, and then it has league name. And I'm going to say q.league.name. So off the bat, when we look at what is being returned, we know for sure that we're getting objects of type team detail. So we don't have to guess and spell and say, what data type can I expect this time? or we don't have to necessarily go to the definition to see what were all the fields in the anonymous type at the time that developer did it, because when we have a strongly typed class, we can always just look at this class definition, and once we know that we're getting this data type, then we just know how to work with it off the bat. All right, so I'm just going to wire all of these up, and then we're going to take a look at the different SQL statements being executed for each and what data is coming back. All right, so looking in our console, we can just go through this slowly. Our first command, which was selecting one property, we see that it's saying select T name from the team. All right, straightforward. You want one property or one column, that's how it's done. No problem. In the next one, we said that we wanted name or the name of the team and the name of the coach. All we did was to say select into this anonymous type, and we specified the columns that we wanted. EF Core generated exactly the statement it needed to get exactly that data. So it selected T name as team name, which is the alias, right? So we called the field name differently inside of our anonymous type. Well, it gave the alias to the column inside of the SQL, and then it did its left join accordingly. We're familiar with the include already, so I'm just really pointing out the targeting of the columns that we want. And then these are the teams that came back. We see Juventus has Conte, Roma has Jose Mourinho, and all the others are blank. That's fine. Now for the next one with a strongly typed projection, it's pretty much the same thing. We're selecting T name, C name as coach name, and L.name as league name. So notice I said name, right? So it didn't have to give this one an alias because that's already the name of the column. So the SQL didn't give it an alias, but then the alias was in place for the other two, and then it went ahead and did the joins. And then when we print it out, we see team name, coach, and Serie A, and we're seeing all the league details. So here we're targeting the columns that we want. So it's going to be a much smaller query, a much smaller payload than just getting every team and every detail of every include to just bring back one time. It is just going to say, what are the fields that I am selecting or I am interested in? Let me get those and then bring them back as a list. So once again, while this is a good facility in a project, especially when you're working with others, I would recommend that you stick to the strongly typed models. You maybe make a different model per type of data you'd want to display on the page, so that when you run the query, you extract it directly into that model and that page is modeled off that data. And if you need to extend it, you simply extend your model and extend your query accordingly. All right, guys, so we're back and we're looking at another topic, and this is going to be a fairly short lesson where we're going to be talking about filtering with related data. Now, what is a scenario for filtering with related data? I have a query here and my variable name is wrong, so let me correct it to leagues. And I am going to query the leagues table, but I am querying the leagues table on something that the team might have. So think of a scenario where you're showing the leagues, you're showing the user the list of leagues, but then you allow them to filter based on the team name. So I know the team name or a part of a team name, and I want to see which league this team is in. So that means when I click submit, you need to go and get me the list of leagues where there might be any team that has a name containing whatever search term. So just imagine that this was a search term coming in from the user, Bay, short for Bayern Munich maybe. And then we're saying here, so let me just take the time to rewrite this query just so it doesn't look as intimidating as it probably does right now. So we say await context.leagues.where. We are all familiar with that. We know that we have the lambda expression. And then I'm going to say where some property meets some criterion. In this case, the criterion is against the navigation property, which is teams. So I'm going to say q.teams, And then it's a list. So I can't very well just say teams.name. It's a list of teams. So I'm going to use any, because any returns a Boolean based on some condition. So I'm going to say any. Because I'm already inside of a lambda expression, I can't reuse the same lambda token. So Q here is already tied up representing a league record. So I can't use Q in the any again. So that's why I have the X. It could be S. Once again, the lambda expression, the token doesn't really matter, but I'm just showing you why I have X in one and Q in the other, because this one is a subset of the larger lambda expression. So X dot, and then now I can access the properties of the team table. So I'm going to say where the name, and then we know the dot contains already, and then the search term, and then we have our executing statement. So that's really all there is to querying against related records. All right, so once again, teams is not the main table. This is the main table. However, our operation requires us going into the child table to match some condition. So if we look at this, our SQL statement that gets generated is just going to give us about the league info where exists, and it's just going to try and select the team based on the search term or based on the criterion that we have specified. And then that would give us back one league, which, if I'm not mistaken, would be Bundesliga. Hey guys, welcome back. In this lesson, we'll be looking at how we can add SQL objects that are not tables to our database through migrations. Now, a case study for this, we have been using migrations up until this point to control most of what goes on in our database. We wouldn't necessarily want to have two separate operations, one where we're going to manually script in the reviews and another one where we're scripting in the tables. So it would be good if we just had a central, like, focal point to our database so that we can always roll back and know that everything that was done in the previous migration can be undone through this particular procedure. Remember that migrations kind of acts like a source control for your database. So in this particular lesson, we'll be looking at how we can add a function, how we can add a view, and then by extension, the same technique that we're going to be using to do all of this would kind of apply to stored procedures and every type of function. Now, I'm not going to get into the details of what the scripts are at this point. I'm assuming that you're already familiar with what a function is, the scalar function versus the table valued function, as well as how our views are constructed. So I'm just going to focus on how we get this SQL into the migration and by extension into our database. Now, as with any journey into anything with the database, it starts off with us adding a migration. So we're going to come to our package manager console, add a migration, and then I'm just going to call it adding team details view and early match function. As I always say, you want to be clear with your migration messages. Don't be vague at all. So I'll just go ahead and add that migration. Now, I haven't made any change to anything with any of the database related elements. I haven't changed the context. I haven't changed any of the classes. So you would notice that these are going to be empty because I made a migration. It didn't say anything to do and it didn't say anything to undo. So we have to manually put in the code for it to know what to do for the up and what to do for the down. So let's look at adding the function. So I'm going to get that function's SQL and I'm going to say migration builder. So what would have happened really and truly is that I went into SQL and made this. I went into the management studio, made the function manually. That's fine. But like I said, I don't want to add it there because I want one point of entry to all database-based modifications going forward, right? So I'm going to say migration builder dot, and then I can say SQL, which is going to take a parameter of type string. So it's expecting the SQL command as type string right there. So what I'm going to do is use my @ to turn this string into a literal string, and then I just paste that SQL statement right in there. So that is what that is going to look like. So migration builder.sql, and then you pass in any SQL. So whether it's SQL to create a function, it's SQL to create a view like we're about to do, or a stored procedure, whatever it is, That's all you really need to do. So I'm just going to copy that, and I'm going to repeat that step with the view. So in this particular migration, I expect to create that function and create this view. Now I did say that, and I said this from before, so we should be familiar with the fact that the up means the change I'm about to make, the down means the changes that I undo, or the things that I undo whenever this migration is being rolled back. So if I have the create statements inside of the up, that means I need to put the drop statements inside the down. So I'll just do that. Migration builder.sql drop view, and then I give it the name, and then drop function with that name. So this is our first time getting our hands, dirt here inside of the migration files. Let's go ahead and do an update database and watch the magic happen. And my experience was not very magical because I have an error. And as I'm looking at it, I see that I have an error in that line. So let me just correct it. I had gotten overzealous and repeated the word matches. So let's try that again. You probably detected it and didn't get that error, and that's perfect. And at that point, everything is done. And if we look in our database real quickly and look at our views, then you'll see the view appearing there, as well as under programmability and functions and scalar functions, there we have our function appearing. So this migration was a success. Now, when we come back, we're going to review how we can interact with a view. Later on, we'll look at how we interact with functions and other scalar operations where we make a call and expect data. But then with a view, it's not really a command. We're querying, and it's going to be slightly different from how we query our tables, and there are certain rules that we have to know about. So when we come back, we'll look at the modifications needed for that. Hey guys, welcome back. In this lesson, we are going to be building on what we did in our previous episode, where we created two non-table SQL objects in the form of a function and a view. So we're going to continue with interacting with the view, because a view in practical terms is really like a read-only table from the SQL side. So that means we would like our application to be able to query those views similar to how we can query regular tables. So what we're going to have to do is create a new data class that corresponds with the view and add it to the DB set. So I've already kind of done this, where I created a new class. I put it in the domain project. I called it teams, coaches, leagues, and I just appended the word view so that, at first glance, we can tell this one is a view versus the others. Whatever prefix, postfix, that's up to you. I'm not being prescriptive. I'm just saying that this is my convention to know the table is different from the views. All right. You could also create a whole new folder and put in a views, call it views, and put all of the view related models in there. However you want to separate them, that's entirely up to you, as long as it's clean and easily identifiable. Now, after creating that class to represent the view and the data coming back from the view, what we want to do is let the DB context know about this view. So I'm going to add a new line in this DB context where I'm going to say DB set, give it the data type, and I'm going to just call it the same name as the view in the database. In our program.cs, we're going to follow suit with what we've been doing up until now, and I just created a method query view, which is just going to have the sole purpose of calling context.teams, coaches, leagues, and putting it to list. However, we're going to see if we will really get back results and if we will get any errors along the way. So let us take this for a spin. Now, as soon as it hits the code, I'm greeted with this exception, and it's saying the entity type requires a primary key to be defined. If you intended to use a keyless entity type, you have to explicitly let it know, that it has no key. All right. So that is expected, and that's an error that I wanted us to see together, because sometimes you're blindsided by that error and you're not entirely sure why you're getting that error. So EF Core, like we've seen, thrives off relational integrity. Primary keys being defined as primary keys, foreign keys being defined as foreign keys, and with that it knows exactly how to make the queries efficiently, how to track if anything is being changed, and how to just monitor everything happening in the context during a request. So by that standard, our new table or our new entity rather, it doesn't know if it's a table, it doesn't know if it's a view, because we added it to the DB context, much like how we added every other table. So as far as entity framework is concerned, it's going to treat it as though it's a table. However, that exception was saying, I don't see a key on this table. We can't put a key on it. It's not a table, it's a view, and yes, it has no primary key. So the exception said that in the model builder, we have to let it know that it has no key. So I have to say model builder dot entity with the data type, and then we just specify has no key. So when it's creating, it knows that, okay, all right, so I'm aware that I shouldn't try to track this. If I find a table or anything that matches this, then I know exactly what to do. Now, another thing that we would want to do at this point is say to view. And to view basically allows us to specify the name of the view in the database that it should look for. So this is like an extra precaution to make sure that it doesn't see any of this as any new elements or SQL subjects or new work it has to do the next time we do a migration. It will just know that, okay, well, this data type, this class type, or this model directly maps to the view in our database by that name. And it has no key, so don't do any tracking. So what I'm going to do is execute that bit of code again, and I'm going to leave that breakpoint so we can look at what's happening in the change tracker. So this time it hits the breakpoint. When we look in details, we would see we are getting back details because the view is executing correctly, and we're getting back coach, we're getting the league, and we're getting the name as we expect. And then the context really doesn't know anything about anything to track, right? As far as it's concerned, it did its job and it's done and it's moving on with life. So that is how we handle situations where there's no primary key present, because you might end up with a table without a primary key or an ID element like that. Perhaps you're forced to deal with a legacy database where those things aren't being enforced like how we are encouraging you to enforce them when you're using Entity Framework Core from scratch, because those situations may exist. But then when you have that has no key battle to fight, then this is the remedy. You put it in the model builder as soon as I can find the context. You put it in the model builder, let it know it has no key, and then you can directly map to the view. Or if it's a table, you could actually say dot to table and specify the name. So there might be times when you have a mismatch between the table name given in the DB context and the actual table name. You can always say to table and then give it that name, much like how we did to view. Hey guys, welcome back. In this lesson, we'll be looking at how we can run queries using raw SQL. Now, up until now, we've been writing everything using our LINQ syntax and our C#, and that's all been perfect. But there might just be a situation where you need to write some raw SQL, and especially now that we're dealing with non-table related objects and we start to see that it becomes a bit more complicated. You know, how do you execute that stored procedure or that function? How exactly do we do this, but maintaining the whole use of Entity Framework Core? So here we're going to look at two examples as we work our way through these different scenarios. Now we have two functions that allow us to execute raw SQL commands, and that's from SQL raw and from SQL interpolated. Now note the syntax: await context dot teams. So we still have to specify our table, and then we say from SQL raw, then we can put in our raw SQL statement and then to list. Now, I must point out some of the limitations here and the dangers associated with this raw SQL. Once you are using this function, you actually open up yourself to the potential of SQL injection if you're not being very careful. So that's why they give you from SQL raw and from SQL interpolated, right? So we'll see the difference in a few moments. So let's look at what we get back with from SQL raw. I'll just comment out the one that we're not using just yet. And from SQL raw, we have to say something like select star from teams. Kind of counterintuitive, right? We just said context.teams, and then I have to say select star from teams again. But let's see what we get back when we test this. Now, when we check our results, we see that we do get back the list of teams and we're getting back every single thing. We did say select star, so we are getting them back and everything is all good. Now, the thing with the raw SQL is that it has to return columns that exactly match the DB set or the entity behind the DB set. So in other words, if I just wanted back the names of the teams and I said select name from teams, right? Or let me keep it simple. ID, comma, well, not simple. Let me use ID, comma, name, right? So I only want 2 columns from the teams table. If I attempt that, then we end up with this exception saying that, you know, there are certain columns not represented in the query set because it tried to query only 2 columns, but it's expecting all. So that's one of the limitations with this raw SQL command. So number 1, the query or the result set must return all the properties of the entity type. Another thing is that the column names must match. So even if I was to list all the column names, I can't give them aliases that don't map back to the original entity type in our class called team. And then another thing is that we can't inner join, so it can't directly have related data. However, I can at this point say include. So after writing out the raw SQL, I can still do my include statements and it would work just like how we know that it will work regardless, right? So if I do that and include the coach, then we'll see for our teams, and I think team number 3 has a coach, and there we go, we'll see the coach entity being included in the form of Jose Mourinho. All right, so that is one of the things that you can do. If you ever need to run this from SQL Raw and need related data, just know that you can do the include just the same way. Now, you're already familiar with SQL at this point, so you know that if we wanted to add a filter, for instance, if I wanted to find the football club where the name is equal to this variable, and we've done it in the past where we actually accepted user input and then use that user input for the filtering, right? So let's just say that we want to use this variable for our filtering. We can always just say where name is equal to, and then we pass in our variable. So interpolation would have us put this $sign before the string, and then we can just do our curly braces and then place name in that area. Now, if we take a look at the SQL that gets generated for that, we will see, which we didn't necessarily look at the last 2 times, that it is generating our SQL statement and it's doing the left join automatically because of the includes. But then take note of this now. What we're doing here is passing in select star from teams where name is equal to, and then you notice that it is passing in the value, but it's not passing it in with quotation marks, because in SQL, we would have had to put where name is equal to, open maybe single quote, the value, and close single quote when we're dealing with a string. As a result, it is complaining that it cannot find the keyword as, because AS Roma is being seen as AS, a command in SQL. So to remedy that, in our interpolated string, we'd have to put our single quotation marks around the value. So let's try that again. And this time we are hitting our breakpoint. So our query was successful. But once again, if you look at this query, compared to previous queries where we did filtering, you notice that there are no parameters. It's passing the literal value directly into the query, aka bad practice, SQL injection. All right, so if you ever have to end up taking some parameter and using a raw SQL command to execute that, then this is what's going to happen, and you have to be very careful, because if somebody passes in some malicious command as their input, then you would have gone back to square one before the days that Entity Framework was developed to help you prevent SQL injection. So in a situation like we employ the services of its close cousin, from SQL interpolated. So if you look at this one, it's asking for a formatable string, right? From SQL is only asking for a string, but then from SQL interpolated is asking for a formatable string, which means that it will only accept one interpolated string. And two, we don't have to treat this SQL statement as literal as we did just now, because it is going to interpolate it. So it's automatically going to handle the parameterization of the command, so we don't have to put in the single quotes around the interpolated or the injected value into the string. So let's take a look at that SQL and compare them. So you see, we looked at this one just now where it passed in the literal value, whereas the second one is actually going to say select star from teams where name is equal to parameter 0, and it has defined the parameter up top. And that is the difference between the from SQL raw and from SQL interpolated. So I would always recommend that if you have to mix and match with variables to pass in a raw SQL statement, use the from SQL interpolated for your own protection and peace of mind. Hey guys, welcome back. In this lesson, we'll be taking a look at how we can execute non-query commands against the database. So an example of this would be when we want to delete or update something that manipulates or augments the data, but it doesn't necessarily return anything to us because we're not selecting. So up until now, we've been selecting and selecting and selecting. Let us look at what we do when we are not selecting, but we have to execute this kind of command. So I have on screen a new migration, add delete team by ID SP short for stored procedure. And I have the code to create the stored procedure called SP delete team by ID, which takes a team ID as the parameter and then it deletes the team accordingly. We have the up and down method, so you can pause, replicate those, and then go ahead and update the database. Now, after you've completed that successfully, you can head over to the program.cs and you'll see I already created the method execute non-query command. Now, when we're going to execute the non-query command, there's few things that are going to be different between this and when we know that we're expecting a result set. And I'm trying to bring up both sets of code on the screen so we can make a comparative analysis. Number one, we are only going to be told how many rows have been affected. Unlike when we looked for the teams, we knew that we were getting back a result set of teams. In this situation, we're only going to get back some variable that says number of rows affected. All right, so that's all we're getting. That's one. Two, when we were doing the other ones where we knew we were getting back data, we knew which entity type or DB set to execute it against, because you wouldn't expect to be querying select star from coaches but context.teams. We know that you just get an error when it tries to execute that method altogether. However, in this situation, since we don't know what the stored procedure is going to be doing, we don't know which table it's directly interacting with, we say context.database instead of context.dbSetName. So context.database, and then the methods that we get are going to be slightly different. In the case of the DB set, we get from SQL raw and from SQL interpolated. In this situation, we get database.execute SQL raw, and it has an asynchronous version to it. So we have raw and we have raw async, hence the await. We're using the async one. And then similarly, we have SQL interpolated async. So we have the interpolated version and we have the raw version. Now, we already explored the bad use of the raw method and the more acceptable, the safer use of the raw method. The same thing applies here. We don't know what the stored procedure will be doing, but we do know that we need to pass in some value, which is more than likely going to be coming over from our user. So we want to protect ourselves and use a formatted string with a placeholder, not the interpolated string when we're using the execute SQL raw async. And then of course, if you don't want that additional responsibility of thinking so much, no problem. That's why they gave you the alternative where you just pass in the interpolated string and it does the same for you. So let us take a look at what we get when we execute these methods. All right, so I'm looking at the SQL that has been generated, and I see here it has been parameterized with team ID 2, and everything looks like what I expected. However, it's telling me that it failed. Why did it fail? That's because of that foreign key constraint that I have on the record. So I have related matches to team with the ID 2. So I can't use that one. That's my bad data. Let me try again. All right, so I'm adjusting my values because I just want to look for some teams that I know don't have any matches. So we shouldn't have any foreign key constraint errors again. Let me try that again. And we hit the breakpoint this time, which means that everything got executed properly. Now, if I look at affected rows, I'll see 1. If I look down here, I see 1. So it only tells you that we executed this successfully, and this is the number of rows that got affected. So if you wanted some flag to say was it successful or not, then you could always say, is the number of affected rows greater than 1? Then we can say it was successful. All right, so that is really it for executing non-query SQL command statements using raw SQL. Hey guys, welcome back. In this lesson, we're going to take a quick look at one of the roads less traveled but essential to know about, which is how to seed data. Now, data seeding, if you're not so familiar with what I'm talking about, is the act of putting data into the database at the beginning. So as soon as your application is installed, there might be default data that you need in there, maybe like a list of countries or certain roles or like a default user, things like that. You probably just want those in the system at the time of creation. As soon as the database is created, these things must be in there. And EF Core allows us to hard code that so that whenever our database is being generated, whether it's being scripted or we're running the update database to get the database up with all of the migrations, we can actually put in code that will be seen as a migration so that when that migration is executed, that data is automatically put into the database from the get-go. So that is what we want to take a quick look at in this lesson. Now, the simplest way to get seeding done is to do it from the on-model creating method, right? So under all of this, we can say model builder dot, and then we specify an entity. So let us say we have teams, we have leagues, we have matches, we have coaches. Let's say I wanted to seed some coaches into the system. So I'm going to say entity coach, and that entity coach has data, and then this has data allows me to now specify as many coaches as I need to. So that's not curly braces, that's parentheses, right? And then in these parentheses, I would now start giving it new coach objects. So I can just say new coach. I can specify the ID from the get-go. So I'm going to use some IDs that I know won't clash with the existing ones. So ID 20, name is equal to, I'll use my name in this situation. And the team ID, well, I can leave those as null because I'm seeding the coach. Now that brings another important point. If you have hierarchical data, then you need to make sure that you are seeding according to the order or the level of dependency. The same way that we want to create the tables with the dependencies, the same way that we need to seed the data with those dependencies. Because I can't be expecting to put in Trevoir Williams, the coach of team ID 5, but then I'm defining the team with the ID 5 after all of that. All right, so let me show exactly what I mean. So if I say team, I want a new team. So I'm going to be seeding a new team, and this team is going to have, let's say, ID 20. The name of the team is Trevoir Williams sample team. All right. I can't be telling this coach that its team ID is ID 20 because the order in which I have defined these seed commands is the order in which the SQL statement is going to be generated. So I can't be creating coach and inserting coach with team ID 20 when team ID 20 doesn't yet exist. So I have to make sure that I maintain my ordering according to the levels of dependency. Now, like I said, you can put in as many as you want. So I have new coach here, and then I can just comma separate as many objects of new coach as I need. So if I wanted 3 coaches in the system initially, of course, the IDs can't clash. And then let's just keep that name sample 1 and sample 2. And then for the teams, well, I can't be the coach for the same team over and over and over, because we know the constraints. So whatever constraints exist on the database, of course, will govern and the limitations you have when you are doing your seeding, right? So you just want to be mindful of all of that. Of course, once again, this is probably when the system is just installed. So I'm using IDs 2021 and 22 because I have teams and coaches in the system already. I don't want to clash. However, in a brand new system, in a brand new paradigm, you would probably start off with 1, 2, 3, 4 as your IDs, because those are the IDs that you definitely want in before anything else. Now, if you were to do seeding for multiple tables, you can see that it can get quite cumbersome. And honestly, I don't like seeing all of that in the on model creating. That's too much code. I want to keep it a bit cleaner. So what I do, or I would recommend you do in that situation, is extract these into like seed configuration classes. So what I tend to do is I create a folder, and I'm going to do it in the data project near the migrations. So I call it configurations, and then I have another folder in there because there might be multiple configuration types that we might want to do. So I'm going to call that one entities. And then inside of that, I'm going to have the different configuration classes per entity type. So for instance, I want a coach seed configuration. Now in this class, which I'm going to make public, I'm going to inherit from entity type configuration. So I'll just go ahead and grab that reference, and I'm going to tell it it's for the type coach, and then include anything that is missing. So for the type coach, I want that. So now I'm going to have to implement this interface, which gives me this method configure and a local builder. So now that I have this builder basically resembles the same purpose as this model builder object. All right, so I can now just say has data. I'm just going to take this part. No, that's for team. Sorry, let me just take the has data part of it. I'm going to cut. I'm going to erase all of this from the DB context, and then over here, I'm going to say builder dot, and then put on the has data. So everything I had has data and beyond fits in perfectly in this method. So builder dot has data, and then you can put in as many seed records in this dedicated class. Now, of course, if I'm moving into a dedicated class, I need a way to make it reference or make reference to it in the DB context. So back in the DB context, I'm going to say model builder dot apply configuration, and then new, and just pass in the name of this method, or sorry, this new class that we created, which is a new configuration class. So I just pass in a new instance of this, and that is it. So as many configuration classes as you create, you just need to pass in these lines, once again maintaining that order. So I did that for coach or coach seeding. Let's do the same thing for the teams. All right, so I'm just going to kind of play it lazy here and just copy and paste the existing file and just change the name to team seed configuration. And then I'm going to update the references in the file. So this is for type team. This is for team. And then our has data section is going to come directly from this. So I'm just going to cut and paste over in its dedicated configuration file. Then back in the DB context, I can just duplicate this and say team seed configuration. And there we go. So that looks much cleaner to me, and it is just as effective as having everything in the file. But of course, this method keeps a bit more kosher and looks a bit better when we do it like this. So let us take a look at what we get when we try to add a migration. And when I do that, I call it added default teams and coaches. I am now seeing that the migration builder is doing something different. We have never seen it do that before. So it's always create table or alter table. Now it's insert data into the table teams with these columns with these values. And it's doing that for everything. And once again, that order matters because see, it took care of all the teams. And then it's going to take care of all the coaches which have dependencies on the teams. All right, so imagine if these were mixed up, we'll be trying to insert a coach with a team ID 21 before the team with ID 21 was even created. Recipe for disaster. So just remember that ordering matters. And in the down, the delete data is just reversing all of those inserts with that delete statement. So if I do an update database, I'm going to get this error. All right, so I'm getting this error saying that I have a conflict with the team and the league ID column. All right, that's fine. So in that situation, I have to modify what's happening with the team because I didn't complete the data. So you have to be aware of that. You have to be mindful of the fact that your constraints will govern if the data can go in or not. So league ID cannot be null. That is a constraint that is on the database. A team has to be in a league. So I can't be seeding teams with no leagues. So I'm just going to quickly seed a sample league. So following the same steps, and I'm going to encourage you to pause and try it yourself. But what I've done is to create a new class that I'm calling League Seed Configuration, following the same steps, inheriting from entity type configuration of type league. And then we're just building one league with the ID 20, once again, to avoid any clashes in the database. And the name is sample league. Then I retroactively go and update my team seed configuration to add that league ID to each of these teams. And by extension, the DB context where I now have that league seed configuration happening before everything else. Now I made a mistake. All right. I generated this migration when the data was incomplete. Now we see that this migration is failing. How do we roll back? Well, the first step is to remove the migration. So that will always remove the most recent migration. And then I can just go ahead and generate it again. And this time, if we look, we see it's creating the league first, then it's going to create the teams and then the coaches. So let us take another stab at the update database. And after the levels of logging and being very verbose, we see done. And we know now that we have this data. So once again, this is now a migration. So it is expected to happen along the chain from initial migration to the very last migration that you might have for your database. So there might be times when you have to introduce different lookups and different tables along the way, and you need these values in as defaults from day one. Well, this is perfect for that. You just go ahead, add in the configurations, and then you can just put them in the DB context. So the model builder will know that when I am doing my build, when I'm creating the model, I need to be aware of these configurations for seeding. Hey guys, welcome back. In this lesson, we'll take a look at rolling back and managing migrations in general. So we've done quite a few activities where we've made a few changes to our database, and with each change, we made a migration and then updated the database. But what happens when you make a migration that you don't quite want, or in retrospect, you want to roll it back, make an adjustment, and redo it? Now, in this example, I've already made a migration, so I'm going to show you the changes I made to trigger this migration. I changed the base domain object to have these 4 fields, and these fields are usually used for like auditing purposes. You know, when you have people entering data into your database, you want to know when it was created, when it was last modified, and created by whom and modified by whom. Now, typically, you'd want these to be kind of clear. So I deliberately kind of named them badly just to show you like a mistake that probably would warrant a correction or a rollback or something like that. So in this situation, if you just look at the column names, they're not really very cohesive, right? Date created, last modified. If I'm just looking at that name, I don't know if this is last modified date or this is last modified by whom. I don't know if this modified means modified date or person who modified it. I don't know. You understand what I'm saying? So these are the things that if you are if you are obsessive with these details, then these things will kind of look ugly to you. However, the point is that I've made these adjustments to the base domain object, which of course is being inherited by every other domain object. So when I generated that migration, which I just called added audit fields, you can go ahead and do that so you can work alongside me. But when I did that, you would notice that it just added those columns to every single table that exists. So over up and down. And then I went ahead and updated the database, which was a successful operation. So as of now, every field in the database has these audit columns. Now, what happens when I am no longer satisfied with this? So we have seen already that when we generate a migration and we realize that there's maybe a mistake with it, we can always remove the migration. But look at what happens when I try to remove the migration. If I go to the command and say remove migration, everything builds and is successful, but then I get this error saying that the migration with that name has already been applied to the database. Revert it and try again. And if it has been applied to other databases, consider reverting its changes. Okay, you see all of that? So in other words, this migration has already been applied. So it cannot just remove migration, because remove migration actually deletes the reference or the record of this migration file from the folder. So it is a failsafe. It's saying I've already made note of this change to the database. So I cannot just go and delete this from the history without you modifying the database. So that's what we're here to do, to understand how we handle that rollback. And it's a pretty simple procedure. I don't know, maybe this error message could have given us a bigger hint or a better hint as to how we could revert the database, but let us do that together. So reverting the database really is an update database activity, right? Kind of sounds contradictory, but just work with me here. So to revert the database to an earlier point in time, what we need to do is run our update database command and actually tell it which migration in time we want to update to, which if it is in the past, it's really revert to. So I want to revert to the migration that I did where I added the default teams and coaches right before I added these audit fields. So I'm going to simply just double click the file very slowly, or you can right click and say rename. And I'm just going to copy that file name. I don't need the .cs, I just need the name, because this is the name of the migration that is actually stored, that timestamp underscore and whatever verbiage you put behind it. So in package manager console, I'll say update dash database again, and then I will just pass in the name of the migration in quotation marks and press enter. And then you see that it has actually done what was in the down. All right. So that's what we talk about when you have the up and you have the down. So the commands that it executed just now were to remove from everything. See there, it's altering and it's dropping the column modified. If you look in the down portion, well, the migration file, sorry. If you look in the down portion of this migration file, that's all it does. It tells it to drop the columns. So that is a practical example of what happens when we one revert, and two, when this down actually gets called into action, it actually undoes everything that the up did. So now that we have reverted or updated the database to a previous version, I can actually go ahead now and safely say remove migration. And it will do it willingly, happily, and without any queries or qualms. And there we go. It has removed that previous migration. So I'm just going to make the adjustments to my base domain object. There we go. So I've updated these column names to be a bit more descriptive of what is going to be in them, right? Created date, modified date, created by, modified by. Now, after doing all of that, we're just going to add our migration again to add the date audit fields. And when that's done, I just want us to take a look at what happens with our date columns. So these are date time columns and they're not nullable. What happens is that when you have a non-nullable date time field in the database, you have to, or it has to put in a value. So that's why we get that default value everywhere that this date time column is going to be added, right? So we can't have no date in a not nullable date field. So it's putting in that default date, which in the database, you would probably see something like 01/01/0001, right? It's just a default date, I guess, since the beginning of time. All right, so with all of that done, we can go ahead and update our database. And I'm going to run that command without specifying any migration. And it is going to be a successful operation. There we go. So now our database is equipped with, at the very basic level, some auditing fields. So when people are entering, of course, we want to know when did they create that record, when was it last modified, and then who created it and who last modified it. Hey guys, welcome back. In this lesson, we'll be looking at how we can manipulate entries before we save changes. Now, a little background to why you would want to do something like that would be coming from maybe the fact that we just added audit fields for all tables, right? So we just added all the audit fields in the base domain object, and evidently this is a bit more work to do because we've seen that when we're adding data, we have to formulate the objects and then add them to the context and then save changes. Now that means that every time somebody adds a team or a league or a match or a coach or anything to the database or modifies it, we're putting extra responsibility on ourselves or our developers to say, always put in the created date, always put in the modified date, at least if we want the data to be standard. Now, doing that in a bigger system can get very cumbersome because we are only working with 4 tables and I'm annoyed already just thinking about it. Imagine when you have 20 and 30 and more tables dealing with. So at this point, it's good to understand how the context actually gives you access to everything that is about to be saved, and you can actually manipulate what you need to manipulate before you save the changes. So I'm going to hop over to our data context here, and it's going to be a quite interesting experience now because we can override the save changes, right? So we see quite a few options of save changes to be overridden. We have the default one, which is when we call context.savechanges, we can override it, and then we can carry out some operations here before we actually save the changes. So you notice here that save changes really returns an integer, which is usually more than 1 when it is a successful save and less than 1 or 0 when it wasn't successful. So if you need to, you can probably incorporate that into your checks to see if it was a successful save operation or not. But for now, we're not going to focus on that. What we want to do is to know how we can intercept everything that is about to be saved and manipulate some of these values before they get saved to the database. So there are quite a few things to be aware of when you're in this area. All right. Firstly, there is an object given to us called change tracker. And I think we looked at this earlier, but let's just look at what it allows us to do. So we have change tracker, and then we can say dot entries. So this actually gives us the list of entries going in to the save changes or being tracked by the context in memory. So I can say var entries is equal to change tracker.entries. Another cool feature with being able to see the entries is to interrogate what we call the entity state. So that's an enum given to us. An enum is just a constant, and this constant has different states that generally represent what state your entry would be in by the time it hits the save changes. So we have unchanged. meaning maybe you did a query, the tracking was on, so it's tracking it, but then you didn't update it, you didn't do anything to it, so it's in an unchanged state. Added, I think that's self-explanatory. You're about to add something to the database. So anytime you create an object and say context.add and then put in the object, it's now in an added state. Detached means that it is not being tracked by the context. All right. Modified means that, well, you took it, you changed something in it, and then you said, here it is. So it was either being tracked when it was changed, so now it sees that it's different from what it was tracking initially, or it wasn't being tracked and you explicitly called context.update and passed it in. And then there's actually another way to update where you just mark it as modified, right? So you can actually just put it in the entity state modified so that the tracker will know that, okay, I should be tracking this as a modified object. Deleted, well, self-explanatory. Anytime we say context.delete and give it the object, it is now in a deleted state. So those are really the entity states available to us, right? But then in certain situations, we may need to track some and not track some. So with the entries, I don't want to see every single entry. I don't need anything that hasn't been modified or hasn't been added, at least for my auditing purposes. Now, once again, I'm just giving you a blanket concept that you can probably adopt for different reasons, right? So you might have some complex audit logging or a second database that you need to write logs to. You may need to track when was this added, when was this modified, is this about to be deleted, and write that to a separate data store. Whatever it is, the change tracker allows you to intercept these entries, do what you need to do, all before the save changes gets run. So let's take a look at that. What we want to do is get all the entries that are about to be modified or added, and then update the respective columns. Right now, we're just going to focus on the dates, right? And then we can go ahead and save the changes afterwards. So I can extend this IEnumerable because this function is just returning an IEnumerable. So I can just extend that and say where, and we can use our lambda expression right here. So I can say where q, or my lambda expression, and then I'm going to look for the state is equal to, and then I can use that enum to filter on added, or q.state is equivalent to entity state dot, I just did added, so this would now be modified. All right, so right here, we're filtering out and getting all the entries that are either about to be added or modified. Next, I'm going to have a for each loop going through these entries, and I'm going to be converting them into the base domain object. So just take a look at what's happening here. Entry in entries. Now, if we look at entries of type entity entry. All right, so when I'm converting it, I can't just convert entry, but I have to convert entry.entity. So entry has a few objects, a few properties. You can see the current values in the object. You can see the original values. So even for audit logging purposes, you can see what were the properties before, or the values on the properties rather before, and what are the values now. You can look at the context, and the entity, of course, embodies the actual entity type that the context knows about. Now, because we use the base domain object and every other entity type inherits from this, I can bring it down to this level so that I can modify the object fields, because at this point, I don't know if I'm saving a football team. I don't know if I'm saving a match. I don't know what entity type is really coming over in the entry. So I'm just casting it into the base domain object so that I can start interacting with the fields. All right, so for each one, I'm going to say auditable objects dot created date, nice and simple, is equal to date time dot now, because I'm about to save the changes. So it must be now that this modification, was done. So modified date, it's the same time. But then think about this now. I am looking for added and modified, but every time something is added, of course, I want to have the created date, but I don't want to have the created date every time something is modified. You see how sensitive that is? So I'm looking at both added and modified, but I am putting in the modified date every time that something is going to get modified. Or sorry, I'm putting in the created date every time something is getting modified, which is wrong. All right, so I'm going to take that one out. So every time we hit save changes, I want to say that it was modified, because it's true. Whether it was being created or it was being modified, its modified date is now. However, I only want to set the created date if the entry dot state is equivalent to entity state dot created, or added rather, right? So when it's going through, it will say, okay, for this entry, I'll set the modified date. So whether it's being created or actually being modified, we're setting the modified date. However, if it is being added, then set the created date. Otherwise, it will just skip this. It won't do anything. It will just go to the next entry and do all of that until it's done. Now, when all of this auditing is finished, the last thing that we want to do is finally save the changes. So this is like a final hurrah. Whatever data came over, we don't know. We don't know what entity DB set type it is. We just know all of these have base domain object in common. And once that is in place, we can go down to the audit fields, regardless of the higher level type, I'm going to say, and then make the adjustments and then save the changes. Now, before I moved on, I just noticed that there are 0 references to this method. So in my program.cs, I have dusted off a few of the old methods that we would have used, and each of these methods does call save changes, but then look at that save changes async. However, we have overridden just save changes. So that's my bad. Slip off the mind from me, right? So the override method that we're really looking for is save changes. So what I'm going to do is rewrite this override, because I think that there are several. So I just want to make sure we get the right one. So we have save changes, and save changes async that takes 2 parameters, and then this one that takes 1 parameter with a default. So I think that's the one that we want, because if we use the other one, then we'll have to provide a Boolean, and that cancellation token is there by default. But then we want the one with the default where we know we don't have to provide any parameters. So I'm going to use that one and just reorganize my code here. All right, there we go. So we're public override task int save changes async, and that is the parameter. So you can go ahead and make that adjustment. And then in addition to that, we need to make this async, because, well, it's async, so we need to make it an asynchronous method. And then if it's calling asynchronous, it's an asynchronous method, which means that we want to use the asynchronous method down here also. So I can just change that one to save changes async, and it requires an await. So I can just pass that await, and that should be it. Just so I have consistency, I'm going to use the same cancellation token in the parameter right there. All right, so that with that adjustment, now I'm seeing all 12 references being made to the save changes. So that's a little better now. All right, so that means when from our program.cs, when we call the context, it's really going to hit our new custom one, and then it's going to do all of this before it calls the base. All right, so that's the power of overriding all of this. So let's go ahead and take this for a spin. All right, and what I didn't point out which methods I dusted off, apologies. So we're using the simple insert operation methods where we're adding new league and teams with league, and I'm doing the simple update league record where we're updating the league record and the team record. So taking a look in the console and the SQL statements being generated, you'll see here that I have P3 and I'm getting that date time value right there. All right. And when it's being inserted, create date, modify date, P2 and P3 are going in accordingly. Here's P1, right? There's P1, which is our created date. And then we have P2 being null because that would be the created by or modified by. So we see that our dates are going into our SQL statement properly, right? So once again, that SQL statement gets generated at the time you call save changes. Now we've overridden it to do some additional things before that SQL statement. So that is a nice little way to inject your own little logic, any little consistency or cleanup or anything like that you need to do before the data actually gets committed to the database. Then you can always override the context methods like that. Now, there is a way that you can extend the DB context even further to facilitate certain things. So in context, we want to put in maybe modified by, like a username or something, to say who modified it. Obviously, we can't do that here because there's no way for me to pass in a string that represents the username as any form of value here, because save changes is only looking for this. So what we can do is extend our context to accept additional data that the default context would not. And then we can massage the data before we call the base context. So we can look at that later on. And I think that will be a fun activity. Hey guys, welcome back. In this lesson, we'll be looking at putting constraints and limitations, general rules around the properties and the values that they're allowed to have. Now, I would have used the word constraint more than once, and that would have been more specific to the migrations where we saw that constraints were getting added for foreign key relationships or for uniqueness and stuff like that. But then those are all migrations based on some of the rules that we're setting up in our on model creating and based on the data types and what we set as a foreign key reference and such. Now, besides those specific situations, there are times when you want to be a bit more calculated and have a more hands-on grasp of what is getting stored and how it is being stored. So a practical example, when we look at team, we see that we have a string for name, which gets translated into a varchar in the database, but then it's varchar max. Do we really want varchar max for a team name? Right? So right there, we're opening up the database to the possibility that somebody could put an entire essay in that field and call that a team name. We don't necessarily want that. Other constraints might include default values. So we had added these base domain objects, and I'm just using these as an example where we have the date time, but then there might also be situations where you want default values in these properties. So if a value is not provided from the interface or from the user, you still want it to have a value. Let us take a look at limiting some of what our string columns can take, for instance. So from the DB context, and this is using Fluent API. So we would have looked at Fluent API earlier when we were specifying certain rules around what each entity can have. All of these lines of codes or blocks of code really are Fluent based on Fluent API. So what we're doing now is using Fluent API for some validation. So I'm going to say model builder dot, and then it is going to be on team this time. So I'm going to say dot property, which it then opens up for another Lambda expression. So I'm going to use P as my token. So I'm going to say P dot, and then I get to choose the property I'm interested in. So I did say name. And then after that, I can now say what constraints it has. So I can say to the database that it is required or it has a specific column type. What if I didn't necessarily want it to be nvarchar? What if I wanted it to be varchar, for instance? What if I want to set a max length, which is what we're about to do? So I'm going to say max length, and then all it needs is an integer value. So I'm going to say no team should have a name that's more than 25 characters long. I think that's reasonable. There are some teams with long names, like Borussia Mönchengladbach over there in the Bundesliga. But I think 25 is sufficient, or let's just bump it up to 50 to be on the extremely safe side. So no team should ever have a name that exceeds 50. Now, doing the rule like this really sets up the constraint for one property, and it's pretty much one property at a time. But I can do this for multiple entities. So I want that same constraint on a league. I don't want any name of a league to be an essay, and I don't want any name of a coach to be too long. All right. Other things that I could do, I could set up this property as an index. So when we talk about indexes, they're really high speed lookup points. So I'm going to remove, I just duplicated that line, and instead of saying dot property, I'm going to say dot has index. And then this is now going to ask me for a lambda expression. So I'm going to just use h like how we're doing index. And I'm going to say the index is on the name. So that means if we search by the name, it should be a high speed lookup point for the data. So the query should run relatively quickly. And I can actually just do the same thing for our league and for our coach. And notice all I'm doing is just copying and pasting and replacing the names accordingly, right? Because they all have similar structures. Other things that you probably want to do would be to specify that these columns should be unique, or whatever value goes in them should be unique. So a case study for that, well, you wouldn't want two teams with the same name, though it is very probable. You wouldn't want two leagues with the same name, though that is, I guess, less probable. But in a more practical setting, if you were doing like a database for a school management system or a book storage, you know, you have the ISBN, which is a unique number for every book, or you have a student's ID number, which is different from the default incrementing ID, but just that ID that they use in school. Do you have that ID number? Then you would want to specify that it is unique. So I could actually extend the has index to say that this index should also be unique, right? And there are other things that you could apply. Some of these I've honestly never used. I've never had a situation where I needed to use them, but that's just me. You can explore and find use for it. So here I'm telling the database that this is a high-speed lookup area on the table team and it is unique. If you wish to have an index on multiple columns, then you can actually just chain this along. So I can make an anonymous object type. We looked at that earlier. So I can just say in the lambda, let's use coach. I'm going to say that the index in the coach table is a combined, or both the name and the team ID should be indexes, right? So I can start my lambda expression, say new open curly braces, so it knows that it's an object type. And then inside of this object, just specify multiple columns, say h.name, h.team ID, comma, separate, etc., etc. And then by extension, I can make all of that unique. So that means that combination should always be unique. So that's more like making a composite key at that point. All right, so I'm just showing you little tidbits. I don't know how practical they are necessarily in this particular situation, but you might just have these challenges in designing your database. And if you're coming from a strict database background, then you know how easy it is, or relatively straightforward it is, to do it in SQL Server Management Studio. However, in the situation that you're dealing with a code first database, you would, like we said, want to manage all of the changes from our entity framework and let them trickle down to the database instead of mixing and matching. So when I've made all these changes, if I go over to the package manager console and add a new migration, and I'm going to say added validations, and always remember to select the correct project. So I just changed from console to .data. Apologies. But now when we look at our alter statements, you see here for the name in teams, it's now varchar 50 and the old type is in varchar max. All right, so there are a lot of performance constraints, performance inhibitions, that can come about by just leaving your data types as varchar max. So when you start putting in these constraints, you're actually making your database more compact, more efficient, and well, just saving the stress of, design considerations down the path in the future. So we have the alter column for the names. So each one is generated nicely. Then we have the create index. So we see here, create index on team's name, and it should be unique. And then we have create index on the name for the leagues, which we didn't specify to be unique, and create index on the coaches table, and the columns are name and team ID. And we looked at that filter code earlier. So I'm just going to go ahead and update the database, and I don't anticipate any issues with that command running. And there we go. We have a red line. All right, let's see what this red line is. So it is saying that create unique index statement terminated because a duplicate key was found. So we're seeing that we have data in the teams table already, and we're trying to say that create this unique index on the team name column. It should be unique. So you can see my teams table here. I have a lot of things repeating and repeating and repeating. But the point is also clear that I can't be saying that the name column should be unique when I'm having AC Milan so many times in the database. All right, so we see that the constraint works. I'm just going to delete everything that is not in the top three. Let's see if I get any other errors. Yes, I anticipated that I would get some foreign key. Let me clean this up. All right, so in order to clean this up, I had to go over to the coaches, make sure that nobody was coaching any of these records I was about to delete. Also go to matches and make sure that none of the records I was about to delete had matches. So that is a practical example of our constraints in operation, right? Because we did set the referential integrity to not be cascade, but to restrict. So those things just cannot happen once those constraints are in. And we're learning how to enforce them using EF Core. All right, so with all of that cleaned up, let's go back and attempt our update database again. And this time, I believe we're going to be successful. And there we go, done. All right, so that is how you can go about setting up validation for your tables using EF Core. Hey guys, welcome back. In this lesson, we're going to be looking at resilient entity framework core database connections. So when we talk about resiliency, it talks about the retry logic. So as it stands, if our application starts and we cannot connect to the database immediately, it's just going to give up the ghost and say, I can't find the database. Please, look somewhere else, or I just can't run. What we would want to do though is build in some retry logic, and this would especially come in handy when we are building distributed systems and the database may be over a huge network. There are times when the packets drop on the network, so something as simple as a blip could affect your application. So what we don't want is to let that quote unquote blip affect the user experience. Yes, we are working with a console app, but the concept would be the same if we're working with a web app or a desktop application. The fact is that we want Entity Framework to be a bit more resilient when it is trying to connect to the database. So what we're going to do in our DB context, and that is the Football League DB context, not the auditable one. What we're going to do here is extend our options builder a bit. So we're already using SQL Server. I'm going to press the comma, and then I'm going to say SQL Server options action, and that's colon because we're just naming the parameter. And then here we're going to say SQL options, which is our object for our SQL options. Now, what would happen is that, yes, I'm doing this on configuring inside of the DB context, but if we're in like a .NET Core application, web application that is, this would be more done in the startup or program.cs based on which version you are using at the time. So the factor means that we would have .use SQL Server with the connection string, which would probably be coming from the app settings. And then you would say comma, and then we are putting in our SQL options. So actually I don't even need that verbiage right there. It's just the name of the parameter, but we are putting in SQL options here. So I'm just going to try and space it out so it looks like it makes a bit of sense, right? So we have the SQL options. All right. And then in the SQL options, we can say SQL options dot. And if we look, we'll see retry on failure. Enable retry on failure. And then that is a method that's going to take a few parameters. So we can say max retry count. Okay, I'll say try up to 5 times, right? I can also say max retry delay. How much time in between? I can say time span dot, and say I want from seconds, maybe try every 30 seconds to connect, right? And then I can say error numbers to add, and you could leave that as null. We don't even have to set that. But the error numbers to add would pretty much, or here it is. This strategy is specifically tailored to SQL Server, including SQL Azure. It's pre-configured with error numbers that are transient errors that can be retried, right? So it's just saying these are numbers that would help you with probably a debugging, probably not absolutely necessary, right? So the fact is that this kind of ties in with our transactions, because when we're carrying out a transaction, we might try to commit and the commit failed basically because it couldn't connect to the database. Now, that's not a good reason to give up on the operation. So we can wait 30 seconds and try again. Of course, the time between waiting and the max retry count, you and your team and your business, you decide what is the best or what are the best parameters for those operations. But as it stands, this is possible, right? You can enable the retry on failure, and then it will do all of that. And potentially that transaction can be committed without the loss of the user experience, because what we may perceive as 5 seconds, the user might just say, oh, well, it's a lot of data going to the database, so I'll sit here and wait, right? So as long as this system isn't timing out or giving them that 500 error, they might just sit and wait patiently, because we're just making sure that their data is going to the database on the first try. So that's really it for how you would make a database connection a bit more resilient with Entity Framework Core. Hey guys, in this lesson, we're just going to do a bit of refactoring and get to understand the full power of our configuration files a bit more. So when we did our configuration files, they were really designed with the intention of facilitating our seed configurations. So we named them League Seed Configuration. But the reality of the matter is that this entire class can be used for all the configurations relative to the target domain object. So in other words, just like how in the DB context, we actually have league related configurations, we already have this league configuration class. We can actually place all of this code inside of that class to further keep our whole DB context kind of clean. All right, because then we'll end up with a lot of these blocks of configurations, and with, as many tables, you may have many configurations. You want to kind of keep everything in chunks so that you can see them or find them very easily when you need to. So we're going to start by refactoring our team. So I said league first, but let's start with team. So we see here that we have this configuration for team, this configuration. We have two others here, and then we have this whole configuration with the seeding. So first order of business, I'm going to rename this from being team seed configuration to just team configuration. And I'll just let that refactor all the references throughout the code. Next up, what I'm going to do is bring over all of those configurations from the DB context. So I have model builder .entity team. I have all of that. I'm going to cut that, and I'm going to come over to the seed configuration. Well, we're going to rename the file in a few. Don't worry about that. But right now, I just want to move over the configuration. So this is the builder has data configuration. I'm going to go underneath that, still in the configure method, right? And then I'm going to paste all those configurations that I just cut. Now you'll see an error appearing with model builder, and that's because we don't have anything called model builder in this file. However, if you look closely, model builder is like a generic version or implementation that allows me to say model builder dot entity and then imply the entity. Our builder object on this type is specific. It's entity type builder for this specific entity. So this whole implementation kind of embodies this entire line, right? So all of this that says model builder dot entity dot team, I can now replace that with builder, and builder knows that it is relative to team. So everything that we do here is relative to team. All right, so I can just say builder dot has many and then just list out all the rules, replace that also with builder, just moving it up so we can see where it starts and stops. And then I'm going to continue with the other bits of configuration for the team. So I'm going to cut that. and I'm going to place it right there. And once again, I'll just use builder to replace that model builder.entity.team stuff. There we go. All right. And then that's our configuration. So we already have that configuration being called right here. So once it hits this line, it's going to jump over to the configuration file and see everything that needs to be done for a team. So I can actually move these configurations above the has data. So let me just rename this file quickly before I forget. And then we're going to do the same thing for the other configuration files. So league seed configuration, it's no longer specific to seeding. So I'm just going to go ahead and rename that reference. Go ahead, rename the file. And then I can bring over league related configurations directly into our builder. Go ahead and replace what I need to replace. And then I went ahead and did it also for the coach. So you can do that now that you have the gist. And at the end of the day, we see our DB context looking much neater. And then all of the messy configuration stuff, they're in specific places around our project. Alright guys, so far we've been seeing some of the new features of EF Core 6, and I'm sure you've noticed that it's just a steady progression from EF Core 3.1, EF Core 5, and now 6. Each one just improves on the previous version, but most of the code that you're probably accustomed to in terms of LINQ, how the DB context refers to the domains, all of those things are pretty much intact. It's just that they keep on optimizing certain things as we go along. Now, there are many other features. Some of them within the context and confines of this course cannot be covered because we really want to get just how EF Core functions. But other features that you will definitely make or take advantage of in bigger projects would be like temporal tables, where if you're using an enterprise SQL server and not just the local DB context like we are here, then you are able to take advantage of temporal tables, which will be keeping a history of everything that happens, which would actually negate the need for our whole auditable DB context that we had to do. If you're using temporal tables, that's what they're there for. EF Core now has an API that can allow you to directly interact and query and write to and interact with temporal tables. You also have the option of migration bundles, which is more like for DevOps situations. So instead of running update database every single time in the package manager console, you can actually bundle your migrations and have a version of that bundle that gets applied during a deployment. So that makes the DB side of a software deployment much easier to happen. Like I said, these are more for enterprise level operations. And for the confines, for the context of this course, we will not be covering those. So I encourage you to check out my other courses on complete ASP.NET Core and the Entity Framework development, where we go end to end with an enterprise application development. And I will be highlighting all of those key features as we go along. And of course, I hope that you are able to apply everything that you've learned so far to your own project and that you're making the best decisions possible.